bring together experts from across the globe for 5 days of top-level content and discussion across pivotal cornerstone and new technologies. The summit will present a series of expert keynotes, interactive panel discussions, solution-based case studies, technical sessions, hands-on workshops, fireside chats, and more. We believe that the Open Source Summit will be beneficial for you all. Let's together build a truly inclusive and open ecosystem. I especially have to mention the sponsors for the event for the summit. The Open Source Summit is co-organized by Fossasia and sponsored by LF AI and Data Foundation, GNOME Foundation, Foundation of Public Code, Netherlands, Blockkites, Block Leaders, CSI Students Chapter, and Felix Events Hub, and our YouTube streaming partner, Code for Course. So I believe it will be going to be a great summit. Wishing you all a week full of open source knowledge. Enjoy the summit. Thank you.
Thank you, Engineer Jacob Picharian. Now I invite Engineer Punnos George, Executive Chairman and Secretary, Governing Board of Saintgits Group of Institutions, for the presidential address.
Hello, am I audible? Am I audible?
Yes, sir. Yeah.
Yeah. Our esteemed guests, eminent activists of free open source software throughout the globe, esteemed principal and head of the institution, Dr. Joseph Kunyupal, the head of the Department of Computer Science, Dr. Anju Pradap, and all the other faculty members, as well as students and other persons who have found time to attend this summit. Welcome all of you on a nice morning of Monday. Today is very exciting for Saintgits because Saintgits have been always believing in the power of free spirit, free speech, and free practice. And any such activity in any phase of human development, which has brought us to the level of present state of our society, is always welcome, and we are privileged to take part in today's summit. If you think about the source of open source, you will find that it has been there for eons, because knowledge is always to be shared and multiplied. That is from the ancient Vedas. Our rishis have said that Vidyadan Sarvadanal Pradhan. In a way, this is the only wealth which multiplies when you give out. And open source, the entire idea is propounding that. And we all know, as activists of open source software, that software, which is the lifeblood of the entire global, commercial, social, whatever aspects of human life, if it has to be charged as it is now, then there is no two arguments on charging on the air which we breathe on the water which we drink. Because you can find arguments for free market economy. I don't know whether pronunciation is correct. It is laissez-faire. We have foreign delegates who can correct me, but I think we have to have a sharing system, developing system, which is above the monetary aspects of multiplication of wealth. And in that way, I strongly believe that our computer science department has taken the right step, especially among the students, to rise above personal interests and to come out into very actively running this summit, as well as the activities of Fossasia, which we have humbly joined. I welcome all of the delegates, especially Julian and Dorothy Cheng, as well as all the other dignitaries from abroad who have found time. And I thank all of you, and thank you for this patient hearing. Let me wind up.
Thank you, Engineer Kunnus George. Now I welcome Dr. Joseph Kunyapol C, Principal of Saintgits College of Engineering, for the felicitation.
President of the function and Chairman, Saintgits Group of Institutions, Sri Kunnus George. Chief guest and keynote speaker, Mr. Brian Belknop. Head of Department, Computer Science Engineering, Dr. Anju Pradap. Coordinator of the program, Sri JKP Cherian. All delegates, faculty members, and all dear students. Fine good morning to all of you. See, due to the various advantages like quality, reduced cost, security, and requirement of no vendor, open source software is acquiring momentum now. At the outset, let me congratulate the Computer Science Engineering Department as well as the Open Source Club of Saintgits College of Engineering for organizing a summit on this emerging area. In the world as such, we are witnessing a paradigm shift from depending on outstanding individuals to rather than teamwork or community developments. In this scenario, programs like open source software has a lot to contribute to the mankind, especially in the situations now we are facing now. Summits like this will provide an opportunity to learn from stalwarts like Brian Bertnoff and share the idea of all those persons who are fascinated by this development. The 5-day program arranged by the Open Source Club of Saintgits College of Engineering is really an exhaustive schedule which will serve the purpose to a great extent. I hope constructive ideas and suggestions will evolve and emerge as a result of this summit. And I wish the program more success. Thank you.
Thank you, Dr. Joseph Kunyapol. Joining us today is Brian Behendorf, the General Manager for Blockchain, Healthcare and Identity at the Linux Foundation and the Executive Director for Hyperledger Projects and Linux Foundation Public Health, which hosts the COVID Credentials Initiative. He was a primary developer of the Apache web server, the most popular web server software on the internet, and a founding member of the Apache Software Foundation. He has also served on the board of the Mozilla Foundation since 2003 and the Electronic Frontier Foundation since 2013. Now, we are really stoked to welcome Brian Behendorf to formally inaugurate the summit and to deliver the inaugural keynote.
Thank you, and thank you to everyone there at Saintgits, esteemed faculty, students, the leadership. Saintgits has been a tremendous partner for Hyperledger for the last couple of years, and a good friend of the Linux Foundation. I'm really sad that I'm not able to physically be there, that none of us are able to physically be there, because I have traveled to India quite a bit for quite a while and helped build and get to know the open source community there. And now the blockchain community is growing really quickly as well. So thank you for the offer to address you at the opening of this momentous occasion. I'm really happy to see a summit like this take off. I'd like to kind of share with you in the short time we have here some news about some information about some activities that are happening in the open source ecosystem to help fight this terrible disease, this terrible pandemic that we have going on now in India. It's still very active in the United States, still very active worldwide. We are by no means out of it by any stretch, but the end is in sight. And there's some really important tools that people in our communities have been building to help us with this fight. And then I wanted to talk a little bit about, since this really is a very broad open source project, just one thought about what I think is still a big challenge for us in open source and something we really need to get better at doing. So why don't I start just by, let me share my screen if this is all right with everybody. I just to give a couple of pictures in this short amount of time. So this is a shot of the last face-to-face conference that I went to, last that many of the people in our Hyperledger community went to. This was a Hyperledger Global Forum in 2020 of March. This was right before basically everything shut down in the United States. This was hosted in Phoenix, Arizona. We had about 300 people there. It was a nice, tight conference covering all sorts of use cases for blockchain technology and ways in which the open source software that we're building at Hyperledger is being deployed all over the place. I can't wait to get back to face-to-face events. I can't wait to be able to see people because open source, it's partly about the technology, but it really is about the people inside and about those who make it work. So in March 2020, this horrible pandemic hit, right? And it suddenly put tremendous strain on us as a society. No, that's you can't put it any more plainly than that, right? And it put tremendous strain on supply chains for all sorts of goods and products, particularly protective equipment. It started to put a lot of pressure on the medical establishment, not only to figure out where, how we might develop vaccines to fight the disease, but also other treatments, but even just where this disease was happening. What were the characteristics? Is it airborne? Is it, on things that we touch? And where is it spreading? And there were a number of places where the open source community rose to the occasion to fight this. There were quite a few open source analytics tools that were further refined and enhanced, and lots of websites. I'm sure you saw visualizations everywhere from the New York Times and Johns Hopkins to the WHO. I'm sure in India there are quite a few of these as well. A lot of those built on the back of open source visualization tools that the community had developed long before the pandemic, but suddenly could be applied to analyzing data sets about where these were happening, right? But even getting access to good data was a challenge. And so there are many groups that spun up, such as the COVID Tracking Project, who basically took as their charge, let's take all the sources of data of where there's cases, where there are hospitalizations, where there's still where the disease is raging. Let's try to pull that information together in one place and clean it and try to standardize on it. And in a way that used open source software. In fact, the COVID Tracking Project, every line of code that they wrote, they published up into a GitHub repo. But it also took starting to globally standardize terminology such as what is a hospitalization, what is an open hospital bed, right? So that we could start to get a situational awareness of what's going on across an entire country or even an entire region. But then two particular places where open source software and open source blockchain technology in particular started to apply The first of those in exposure notification apps. I'm not sure if any of you are familiar with it. I'm not sure if India has one deployed like this yet, but around the globe, there have been these apps that use Bluetooth Low Energy to try to keep tabs of who you've been close to and do that in a privacy preserving way, so that if you test positive, you can work with a public health authority to report these codes that you saw, and then people who match those codes get notified you might have been near somebody who recently tested positive. In some countries, they deployed this quite successfully. In the country of Ireland, they deployed it, and according to their tracking, and again, this is in a privacy preserving way, so there's no central knowledge about who was affected or who wasn't, hundreds of thousands of potential chains of transmission were blocked by somebody getting that notification and going, okay, I should probably lock down, I should probably get tested myself, I should probably, try to reduce my exposure going forward. And in country after country, there certainly were varying degrees of success, but there were quite a few deployments of this, and many of those were deployed using open source software that came from a sister project to Hyperledger at the Linux Foundation, known as Linux Foundation Public Health. And there's lots more information you can find on the LFPH website about these, but it was a success. I mean, there's still a lot of work to do, and still a lot of ways in which the technology could be improved. The open source community continues to look at those ways, and I think particularly as people go back to work or they go back to school, having tools like this ready to be available if there is another outbreak somewhere, or a disease that's a variant of the disease that escapes the vaccines, for example, will be able to stop it before it spreads too widely in an uncontrolled way. And then one more important use case to bring up. I mentioned how supply chains were being strained, and it involved a whole lot of new people buying things like masks and gowns from the States or from Europe or from there in India, from businesses that they had never heard of before. Businesses based in Asia, businesses based all over the place. And in many cases, there was no history between buyer and seller to depend upon. They were new to each other. And so there was a network that was launched actually just before the pandemic called Trust Your Supplier. Trust Your Supplier is a platform. It uses blockchain technology, open source technology, actually, something called Hyperledger Fabric, and it's run by a whole lot of different participants in the supply chain to act as kind of like know your customer, but for suppliers, right? It keeps track of who sent materials to who, what's the history that's been developed. And so when somebody is new on the scene, a new supplier, somebody else was able to see, oh, here's some of the first successful deliveries that have gone through. I can trust that person versus somebody with absolutely no history. So that was put into production. There have been quite a few other supply chain networks, those set up by shipping giant Maersk, for example, others such as the Food Trust Network with IBM and Walmart, that came into quite a bit of heavy use in the last year and a half to help meet this sudden surge and this additional complexity of addressing the needs during COVID. But one of the biggest use cases of interest of late, and one that I know is going to raise there in India in interest, is being able to show once you have received the vaccine, or merely if you've tested negative on a test for COVID-19, being able to prove that so you can get on a plane, or so you can go back to work, or go to some sort of public place that might require that. Obviously, it's controversial when and where that's required. But one thing that everybody can agree is super important is that it needs to be privacy preserving in a way that perhaps goes beyond what traditional digital identity technologies have required. And it's required for many countries, especially in Europe, for example, where privacy is of huge concern, and they want to avoid creating a trail of every place everybody has gone. This new technology, this new approach to digital identity called self-sovereign identity has really been called for. And the most mature deployments of self-sovereign ID have been built on top of two pieces of open source code, Hyperledger Indy and Hyperledger Aries. And that's been the basis for a number of these kinds of travel pass systems, or something in New York City called Excelsior Pass, all sorts of these apps to try to reopen these. And to just take you really quickly through how that works, there's three parties to it. There's a holder of a credential. Any of you, for example, if you receive a vaccine, you have a digital proof of that or a test result, right? There's an issuer, the person who gave you that vaccine or conducted the test. And then there's the verifier, the person standing at the gate to get on a plane or go back to a work or to a concert and looking to verify this, right? And the issuer and the verifier need to have some common bridge between them, so the verifier knows whether they can trust the signature on this credential, as it's called, that the holder presents to the verifier. So typically there's this verifiable data registry between the two of them. And in India, of course, you have a system called Aadhaar, which does that for so many of these kinds of connections. But for many people, they wanted something even more privacy preserving than that, something where there wasn't a central registry keeping tabs and able to know who was presented, where people presented those credentials. And so there's the self-sovereign identity space evolves the verifiable data registry into a concept called a governing authority, basically a decentralized network where the verifier can verify the validity of these credentials without the issuer being told, without even any central party being able to know whether that's being verified or not. And those governing authorities might be states, they might be nations, they might be somebody like the WHO or IATA, who runs a lot of the IT for the airline industry, but they might even be something very local as well. In fact, it's anticipated that there's really a universe of these trust registries and governance authorities that all interoperate. And you, as the holder of this, you should be able to take your proof of vaccination that was issued by one party and cross a country, cross a border into another country and present it and have that verified and have that proven, just like you could with any other kind of credential, right, that we expect in the real world. So this is needs by virtue of the fact that we're a global society, needs to be distributed and decentralized. This by its nature calls for open source software, calls for blockchain technology. This is a core focus now for the Linux Foundation Public Health Initiative, where we now have a number of such projects within our open source community focused on software for issuers and holders and verifiers using a common set of standards, the standards for self-sovereign ID established by Hyperledger Aries and Hyperledger Indy, but also this larger community in the digital identity space we're working with. In fact, this particular interoperability challenge is now made possible by a collaboration between Hyperledger, the Linux Foundation Public Health Initiative, Trust Over IP, and ID 2020, known as the Good Health Pass Collaborative. I'm happy to share your links to all of that in chat when I'm done with my talk. But this is really exciting because this is how open source software, open standards, and open collaboration will really help reopen society as we get to the point where more and more people get vaccinated, where we're able to get the disease down to a more manageable level and really try to keep that or any new variants from spreading into new countries. This is how we win this fight. But I wanted to just pivot back before turning the microphone back over and talk about one idea I wanted to share that has really been important to me recently around open source software, but I want to start by talking about chickens. I raise chickens, not professionally. This is something my wife and my daughter, who's pictured here, and I do kind of for fun off to the side. This is a picture of her with a younger chick. And I wanted to talk about chickens because I recently read a really fascinating thing in a newsletter put out by Tim O'Reilly called the Next Economy newsletter, where this was about a couple of studies that asked the question, is there such a thing as too much competition? And it resonated for me because in open source software, take almost any type of use case, and there's generally speaking more than one open source package that does a thing, right? In the blockchain technology space, even within Hyperledger, we have 6 different platforms for building distributed ledger systems. How many different open source databases do we know about? How many different programming languages are there? And in open source software, we're a lot of pieces that have joined up together to build larger things. And that can be a challenge sometimes when we have just too many choices, right? And so often this question comes about, how do we work together? How do we merge efforts, if that makes sense? How do we help people pick what's going on? And And I wanted to turn to this anecdote, this story, because it resonated for me, and I think you'll see why. So there was a researcher named William Muir who conducted a chicken breeding experiment where he tried to see how do we get hens to produce more eggs, right? So in typical breeding kind of format, he chose the most productive hens and put them all in the same hen house together, and hoped that through selection he would be able to breed more and more increasing hens. But what he found is that when he put those hens together, there was an increase in aggression between these hens. There was lower egg production overall and fewer chickens overall due to hyper-aggressive hens. By contrast, when they breeded not the most successful hens, but the most productive groups of chickens, right? The small groups of 10 or 20 chickens that as a group produce the most. If they bred those and tried to improve the productivity of those as independent groups rather than selecting like the alphas from each and putting them in one, then they found instead a 160% increase in productivity. And by focusing only on increased egg production, other tasks essential to the maintenance of the environment, often performed by weaker members, were ignored or the environment was damaged. So the inclusion of individuals who contribute or promote cooperation or consensus building proved to be far more beneficial. Now, I'm sure you've all seen open source projects where you have the alpha developers, the ones deep into the guts of the kernel or the file system layer, and that's okay. You need those kinds of developers, but you also need the people working on documentation. You also need the people answering new user questions as they come in. You need people thinking about how do we build a bridge with other projects out there? How do we cooperate with others? And so this resonated with me, as did the conclusion of a lot of this, which was, it came from an evolutionary biologist named David Sloan Wilson, who looked at this, which said selfish individuals outcompete altruistic individuals, right? We think of like, these alpha competitors out there running a race or something like that. But altruistic groups outcompete selfish groups, right? So whether we're talking about chickens or we're talking about software developers, like the more that we can get the communities working well and thinking altruistically, how do we help each other create the best software, whether we are the alpha developers or we're helping new people over, in through the front door. That to me speaks to the kind of open source community I think we want to build. So let's be a community of altruistic groups. Let's figure out how to build great open source communities. And I think a natural byproduct of great open source communities is great open source software. And I hope in not too much longer, and maybe perhaps thanks to open source software, we'll be able to come together again soon. I'm really eager to come visit Kerala and of course the greater subcontinent, and really eager to see all of you face to face. But for now, I'm really happy to be able to present to you. Thank you, and on to a great conference. Thanks. And I'm done. I guess I could ask for questions.
If you have any questions, you can drop it in the chat.
I might have scared everyone away by talking about chickens. I apologize. Okay, well, if there's no questions, I will hang around for a little while. Feel free to reach me in chat. I'll drop some links in chat as well. But thank you again, and I'll hand the microphone back now to my host. Thank you.
Brian, just a minute. I could see a question on the chat, and it's actually written, many countries have considered deploying a COVID credentials or health pass to assist in safely reopening their economies. So how this COVID credential initiative can help in a solution which is privacy protecting, interoperable, and how can we kind of ensure that it is built on open source standards? Right.
Well, I'll drop links in chat to a number of the different groups that I talked about there. I think if you are working with government or a government official yourself, or able to carry on a conversation at the level of of the national health authorities or even regional health authorities, we're very happy to talk with you at Linux Foundation Public Health. We're really the first open source project at the Linux Foundation focused on meeting the needs of government authorities when it comes to public health. And we're very happy to help explain how the technology works, help point to potential solutions, point to potential service providers, companies that can help you deploy these technologies, and show you kind of the universe of people working together to make these technologies work. So yeah, please get in touch.
Awesome, thank you. So if you have any questions, you can drop it in the chat. Any questions related to open source, how to contribute to open source community, because he is really involved with open source and all the stuff, especially for the Apache project. So if you have any doubts, you can drop it in the chat.
Okay. Should I take this one or should we move on to the next?
Thank you so much, Brian. Much more of a beginning than an end, as we are expecting many more conversations together. Thank you.
Great.
Thank you, Brian. We know that joining us at this time is really challenging with your time zone. We are extremely grateful to you for joining us today. Thank you so much. With that, we are officially winding up our inaugural session. A whole bunch of interactive sessions are waiting for you. Today, we will be having expert keynotes, technical session, and interactive keynotes from industry leaders and top-level sponsors, all virtually showcasing the open source ecosystem trends. A gentle reminder, participants are requested to kindly mute their microphones, and if you have any questions, you can drop it here in the chat so that speaker can either weave them in the conversation or can address it at the end of the talk. We will start our next session by 10:15.
Mario, can you hear us? Mario?
Hello?
Hi, Mario. Can you hear us?
Yes. Oh, thank you very much. I can hear you.
Yeah.
Okay, excellent. So, yeah, cool. So when are we starting the session?
We are going to start now. Yeah.
Ah, okay. We are already starting now. Okay.
Yeah,
Well,
there will be an introduction. After that, you can officially start.
good. Okay, nice. So then let me...
I think your video is off.
Yeah, I'm preparing.
Okay, okay, fine.
Welcome all. Mario is a technologist who is fascinated by the power of sharing and collaboration. He co-started the Fossasia organization and projects like Eventia.com and Pocket Science Lab. In Afghanistan, he deployed mesh networks in schools. In Vietnam, he built an eco-hotel from scratch. He is currently working from Berlin, where he runs OpenTech, a company that develops open source and open hardware solutions. I welcome Mario Belling to deliver a session on best practices in software and hardware development.
Thank you very much for this introduction. And yeah, I very honored to be at this event. Yeah, I've been in touch with organizers here from the event. We have participated in like workshops together. Jacob here as one of the main organizers, he has like helped me to learn more about your community. And yeah, I really appreciate all the work that you are doing there. And yeah, I'm very happy to be here at your event. So today I'm going to talk about best practices in software and hardware development. And I also have prepared here some slides. I'm going to share my slides here now. Yeah, give me a moment. So I will do that. Share screen. So you should be able to see my slides. Is that correct?
Yes, Mario, we can see the slides.
Ah, okay. Yeah, fantastic. Okay, so yeah, we are here today at the Open Source Summit Saintgits. So unfortunately, we can't meet in person, but yeah, I like this picture here from one of the Fossasia events in Singapore. It reminds us like how nice it is to get together, and I hope at the event we can create some of this spirit and some of this connection nevertheless of being together. And yeah, hello all the way here from Germany, where I am at the moment. At this time of the year, I'm usually maybe in Singapore or Vietnam, as we like collaborating with developers from the open source community there. So yeah, it's not possible right now, but let me say a virtual hello. And a little short background about me. I lived 10 years mainly in Singapore and Vietnam, and now like I'm chatting around usually, but that is my connection to Asia. And I'm here the CEO of Open Tech. We are working with like 19 partners in Europe, supported by the EU, and we develop software and hardware. Personally, I love to learn languages. My mother tongue is English, and I really like Indian music. I have some favorite songs that I always play, and at the same time, I like Latin music and drums, and I feel there's really a global connection that we have through music. And I also see this connection in open technologies, solutions for many years. And I would also like to introduce the partner here in Fossasia, and this is Hong Phuc Dang. She's originally from Vietnam, studied in the US. We co-founded the organization together, and she's a member of the board of the Open Source Business Alliance. It's a open source business association run from the European Union with 1.5 like representing members with 1.5 billion revenue per year. And Hong Phuc currently also like does inner source at Zalando, the biggest online retailer in Europe. So how did we start Fossasia? To give you a bit of background, we started it with with collaborating with another community when we hosted the GNOME Asia Summit 2009 in Vietnam. And at that time, we were already working on Linux development and web tools for companies. And we continued to run the Fossasia Summit over many years in Cambodia, in Vietnam, in Singapore, but we also have events in China. We had Jugaad Fest, for example, in India. So a lot of things are going on. So here, for example, a picture of the Fossasia Summit in Phnom Penh, 2014. Very nice first time that we run event outside of Vietnam. The event, like Fossasia, originally started in Vietnam. But we connect more and more through the years with other developers and interested students, and in the educational area. Here, for example, in India, you can see some of our contributors who then later joined into projects as well. So we have, on average, like a merged pull request every 15 minutes in our repository. So originally, Fossasia was an event organization, but later on, people said, okay, we have ideas, we want to start some projects. And we set up Git repositories, and today we have also many mailing lists, 40,000 developers on mailing lists and on social media that are connected directly with us. And we have 5,000 people who are registered on our GitHub organizations. We're also training around 2,500 developers through coding programs annually. Some are online, some are also offline, face-to-face. And we have many meetings, hackathons, with a focus in Asia, of course. But we also even created a hotel, small hotel, where we can get together for developer meetings or run workshops as well in the Mekong Delta in Vietnam. And we wanted to prove here that software is not just for online, for like building websites and so on. So with the hotel, we also try to use as much as possible open source. For example, on the computers, we use Linux, or some routers. We also use Linux or OpenWRT, things like that, really making it practical, not just as an abstract ideas. So what are our projects? Here you see, for example, information about one project, which is called Eventier. And Eventier was developed since 2015. And the reason for this project was that we didn't find a suitable event system that had all the features that we needed. For example, there are like pretty good systems that are not open source, like Eventbrite also. And there wasn't really a system that could do speaker handling for us at the same time. And we were like really unhappy with other systems that like Eventbrite, right? They charge a lot for us, but we wanted to deploy it ourselves and change some of the configurations and so on. So yeah, this was the reason for starting the Eventier project. And yeah, we use it, for example, for the Fossasia Summit itself, and it can support like thousands of people. So that's not a problem. It's an offline system for offline ticketing, but it was later extended for online ticketing. Here are the requirements that we have, or that we had back then for the project. It should be free and open source, of course, with free and open source licenses. The technology stack should be, with the technology that the team knew about. It should keep privacy in mind, following open standards, open APIs. So the original ideas was that the ticketing should be similar to Eventbrite. We wanted to make things similar because, there are people who maybe use the system who don't know about it. It should also have an easy process for registering speakers, different team roles, and so on. And yeah, ability to support Android and automatic websites, all kinds of things. So that is one project. Here's an overview, all in one: ticketing, scheduling, check-in, video conference, and so on. So we developed a lot of things, and ultimately plugged in is also solutions like Big Blue Button or Jitsi. Here you see an example. This is also on Fokir, by the way. And so the ticketing now works, and then you can also get access to a Big Blue Button or Jitsi video calls, so they are integrated now. Okay, so, but then we also work on other projects. For example, one idea here: let's build your own personalized open textile production line. Hongfuk gave a presentation here on the 31C3. It was a huge conference with like 13,000 hackers in Hamburg that year. And the idea is nothing less than let's make a revolution for the textile and garment industry where the system is broken. We also see that in India, for example, the textile and garment industry is like often very harmful to the environment. It also doesn't provide very good working conditions, sometimes even dangerous for people to work in this industry. And the question is, what can we contribute? What can we improve here with technology? And one idea is to digitalize machines, to digitalize production, to substitute, for example, like some manual labor with really digital production, where you can, like, for example, add comments into the computer, and then you could use garments. So I have a video here that I will link to you later on. You can watch it, and for example, here on the slide you see a digital open source knitting machine, which is one of the things that we worked on, that we released. And I'm going here to the next slide then. So you heard a bit about machines that we're interested in. For machines, of course, we need hardware here, like, for example, PCB boards, all kinds of things. And then there was another idea, actually, with Praveen. He came to us and he said, I'm a physics teacher, and I need things like an oscilloscope. I need other mini devices to teach my students in the physics lessons. So that was pretty cool. We had this project then, which is called PS Lab. And PS Lab is still a very active project these days. We produce a hardware board. This board here is then used for different use cases here to in the physics sector. So it's used for control and measurement tool. It's also a robot control tool. Can be used through different pins. So you can connect, for example, sensors here. You see the pins of the device that you can then access. You just plug in a small cable and you can control this board. It can be controlled through Android app, through desktop app, or you could make your own apps. So here's a picture how you can do that. So basically you plug in a cable that you see here in the Pocket Science Lab, and then connect this cable to your phone, and you can control the PS Lab then through the phone. So then you have different tabs, oscilloscope, for example, or multimeter, and you click on these tabs and you can access the features of this instrument that you want to use. Here are a few more examples. What can it do? It can function as an oscilloscope, multimeter, logic analyzer, wave generator, power source, accelerometer, barometer, compass. You can plug in like tons of sensors and yeah, for example, a lux meter. So when you use it as an oscilloscope and you have like, for example, sound waves or yeah, different kind of waves, and your sensor then accesses it as a sensor is, for example, a microphone. Yeah. And yeah, by the way, you can even like try with the app to use the microphone of the mobile phone. The mobile phone also has a microphone already, right? But the device, of course, has much more sensors that can be used instead of only having the sensors of the mobile phone. But this is what you see then. Different waves can be like recorded, for example, a sine wave, a square wave. Yeah, can be shown through oscilloscope. And yeah, in the next version, something really cool happens. You can even record different yeah, measurements and then record data without the phone. So basically you configure the device and then you transfer your configuration to the device itself, and then the configuration, for example, will record that you set. Even when the phone is not connected, of course, you need to have a battery connected that it runs. Yeah, and apart from sensors, you can control, for example, robots with the device. We have support for up to 4 servo motors, which you can see here. They're very cheap motors also supported, even like some only cost $1. And then like here on the left-hand side, you have the screen where you see, for example, numbers. These numbers can lines of different servos. Then you can have a timeline, just in video, just like in video editing. And yeah, at certain times, it's moving up and down. Yeah, and it's not just that we make a hardware board, we actually produce the entire thing also, and we sell it online on the internet. Here, for example, in the middle, you see our partner, Wei-Ted Chung. He is helping us to produce it in China. And we also have first batches now produced in Europe. So the idea is that we can produce around the world. And then we educate people to use it. For example, here in Singapore, at the Maker Fair, also at our own events. And then we have other hardware that we're interested in. For example, the open hardware Neural Lab, like a device that you can attach onto your forehead and then collect brainwaves with it. Yeah, so it's a pretty cool thing. It's also, again, measurements similar to the oscilloscope, where you collect waves here, for example. And yeah, that's how it looks like. You can, of course, find the schematic online. It's open source. There are early prototypes available, so it's not yet produced in larger quantities. But yeah, if you have access to a lab or something, you can already try to use this project. This is the current status. What is there? High quality schematics in KiCad. Bill of materials, BOM stands for bill of materials. There's a firmware, this Android app, but like still a lot of things need to be done in order to also bring it to the market. You can see there's an app where you can, for example, collect data, and yeah, it's pretty cool. For example, you can use it for meditation, collect your data, meditation, and check, are you really able to calm down your brain waves, to calm down your brain when you meditate. It can give you information, it can give you feedback. How are you performing? How are you relaxing your brain, for example? Or are there any sicknesses, and so on? So these things can be analyzed then through the data that is being collected. Yeah, there's a focus app. There's a small game even where you can use as you can see here on the picture in the middle, you can use your brainwaves to control the speed and the height of a small rocket that is flying somewhere. So yeah, just through your brain, just by thinking, rocket, go faster, go slower. That's the idea. So how do we work on all these projects? We work on these projects online, but we also meet at many events. Yeah, as you can see, people from all over the world actually join up with us and help us to develop this hardware and this software. And yeah, that is one way how we work together, by meeting people and asking simply for their feedback. This is part of our way of working. We want to create a sense of ownership in our projects, and let developers take control, take responsibility of code development, and let them enjoy a good degree of freedom, so they can thrive. Not just like telling everything, every step beforehand, but people should work together freely, and that's perfect then aligning with the idea of open source. And if open source is not just a license, it's a way of collaborating together. And we have developed our best practices. I want to share a little bit about it here. And and I hope that you will benefit from it and learn from it. So one way of collaborating and speeding up our way of working together is, for example, by using a kind of Scrum. Scrum is a method for collaboration, and we adapted it for our projects in an interesting way. We have it here in our mailing list and in our projects where people work full-time on our projects, and they will write every morning an update of what they're doing and sharing this with their collaborators. And we basically always answer 3 questions. What did you do yesterday? What do you plan to do today? And what is currently preventing you from achieving your goals? So for example, is there any blocker issue in any of the projects why you cannot complete one of your issues? Yeah, and that already gives you a pretty good update every day. Then emails is not so good for communication. Sometimes emails get very long and you need immediate feedback. Therefore, we use chat here, and we still like focus on less discussion and more code. Don't always want to discuss about every single point, rather say, show us some code, and then we can work together and collaborate on this code. But like if you have like some immediate feedback, we can exchange this here. So our goal is to reduce communication overhead. So not just like more communicate and yeah, what do you think, this and that, and how do I do this? Rather like really work on code itself. And this way we also avoid trolls. Nowadays, it's a issue on the internet. There are always people who like have fun disturbing others maybe. And by saying, yeah, let's focus on code, we avoid this. And we always look for the right place for specific feature discussions. It could be on the chat, but if it's going too much into detail, and also if we need an asynchronous way, yeah, where people can respond in different time zones at different times, we try to focus really on issues on the issue tracker here of GitHub, which we are using. And we try to make the development flow clear and structured, where we have usually a development branch and a master branch. So there's a possibility of having different branches in Git, of course. And another way, another thing that we're doing is we allow newcomers to join projects easily. Of course, newcomers will not have right away the rights to merge new code into a project or something like that. But by having issues, by having like a page where everyone can join Fossasia projects, we make it more easy than other projects to actually join and get familiar with the projects. So this will help us to scale up more easily and also to reduce communication overhead. Then our best practices then for projects where we really focus on step-by-step development is we try to merge every pull request with an issue. So rather than saying 5 issues will solve, or 5 issues will be solved by one pull request, right? We try to really say, here's an issue, and you know, this pull request solves this issue. It's not always 100% working, but actually in really most of the cases, yeah. So you say, here I have one problem, and this pull request focuses on this problem, rather than saying I solved this. Well, it helps to stay focused, yeah. And larger issues, like large problems, yeah, we try to break them up into smaller issues so they can also be reviewed more easier by others, yeah. I mean, if you have like an issue with like code over several pages, you know, it would be difficult to review and it would take a long time, and maybe you find several problems with this. You know, it's easier to focus on something small, solve it, get it done, and then move to the next part then that you want to solve, move to the next issue. So let's keep it small. An issue in a perfect world should not take longer than 1 day, but you have to see, yeah, some things like we knew you need to be flexible. However, this is the main idea, yeah. So then our peer review process in most projects, the process is like that we will have at least 2 people who need to accept a pull request, and then the 3rd person can merge an issue or merge a pull request. And it should be like the 3rd person, of course, needs to be somebody who's a core developer in a project. They will have the right to make this merge then. And but these people, yeah, the core developers, you can become a core developer. You can earn write access if you make a lot of good pull requests. If you contribute regularly to a project, you can become a core person. It happened many times, and yeah, you can write more pull requests and earn the access also to merge other pull requests. We basically always try to make things easy for project maintainers, and yeah, that's our goal. So everyone can then become a project maintainer over time. And then documentation is part of the daily development practice. So if you change something, we also like request you to really document it. So We motivate developers to work efficiently, produce fast and qualitative outcome, and we want to do this in a fun way. So we invite people to really like work on problems that they are interested in, and we give them recognition, provide opportunities, for example, through development programs. We have prizes. Sometimes we collaborate with the UNESCO and others, and we have contests and jobs in our startups and spin-offs that we collaborate with. So there are always opportunities when you participate in the community for a long time. So this is something that we need, right? I mean, like we have so many problems around the world. I mean, of course, we have the ongoing climate problem, we have environmental problems, but in the last 2 years, we also saw that we had this horrible pandemic. And we see, for example, that companies in Europe or the US, they have the ability to develop vaccines or to fight the pandemic. But like they don't always share the knowledge, they don't always share what they learned, because this is how the world works, right? I mean, you make an investment and then like it costs you a lot. You have to pay every single person, you have to pay a lot of people, and they say, okay, we need patents, we need to really protect everything that we do because of our investment. Yeah, and it's all about money. But the interesting thing about open source is that we showed that you can actually share every single line of code, everything what you do, and there are a lot of business models that you can use and that even work with open source. I mean, like these big companies like Google and Facebook and so on, they built their entire business on open source. Yeah, I mean, Google could have never even started if they have had to pay Microsoft a license for every single computer. I mean, back in the time, Windows was a thing that you had to pay substantial money for, right? So, but like they used Linux from the beginning. They developed a lot of tools themselves, but they basically took like most of what they do is like, right? Like they took open source to do it. And so there are a lot of models to show how you can earn like a huge income, actually, in many cases, when you use and develop open source. So I think we need this in many different areas also. And Fossasia has shown how to transfer this model of developing open source software and earning an income to hardware even. And we are going to see this in more and more areas. And the people who take advantage of this kind of model, they will be ahead of others. And we also need it a lot for society. Society can benefit of it by sharing global knowledge. We can solve problems of the world, which are difficult to solve otherwise, right? As we see in the pandemic, like still a lot of people don't have access to good vaccination. Sometimes the vaccines, let's say from China also, they don't seem good. They're not efficient, don't protect people. And what we see in free and open source software and increasingly hardware, we also need to see it in other areas to solve the problems of the world. We need open access to knowledge and information. We need now open science, and we need to be able to produce these solutions locally. Yeah, because shipping it around the world also takes a lot of time. It's complicated. We last year we had this thing where the Suez Channel, like this important trading route, was blocked for several weeks, and then suddenly like some things weren't available in Europe or in Asia or somewhere. Yeah, so we need a local production, circular economy that provides income for the many. So we don't have to abandon the whole economic system. We can like change it, we can adapt it, and open source can help us to find models that work in that way, where you share everything, but still have a business model. I mean, it's if you think of it, for example, a hairdresser, everyone can cut hair. Everyone has a scissor. Yeah, so that's not a secret how to cut hair, for example. But you see that like some people have like very cheap, like on the side of the road somewhere, but they're cutting the hair. Other people cut hair for stars, yeah, Shah Rukh Khan or some people, they cut the hair for them, and they earn a lot. So it's basically free knowledge, and we see this more and more in other areas as well. And of course, then also we have to give respect to our users, provide them with privacy tools and human rights, not use technology for the oppression of others. So by sharing this knowledge about technology, we can ensure that many people have access and are staying in control of technology, different to what we, for example, see in China. So all this is possible by leveraging the advantage of open collaborations. And yeah, we have proof it works, and we have the ability to make openness work. So education is a big part of our work here. We need to train people, for example, about these best practices that I just shared with you. Yeah, we need people really to train on it and learn on it hands-on. Hong Fook is doing that here, for example, in the picture in Vietnam. And yeah, working with students, we have workshops in Vietnam. Then here in another place, Ho Chi Minh City, we have science hack workshops. In Singapore, with the main office of Fossasia. And we have programs like Keynote. We have internships, always looking for interns. Usually how it works is you start in a coding program, or you start contributing, and then you will be pretty fast, pretty quickly, you'll be invited to become an intern. So for part-term interns, let's say students, currently we pay 20K rupees in India, but we also have full-time positions. And we have developer positions, like our usual salary in India is 6 to 10 lakhs. Yeah, if you're interested, would be great. How to join? Very easy. Just start contributing. Look for projects that interest you. For example, one of these 3 projects that we have here. So eventjay.com is a project that I introduced here, Python and Flask. We have the Pocket Science Lab. There's even hardware involved. If you're a hardware developer or electronics expert, could be interested. But also for software people, currently we have also 2 interns here in the Google Summer of Code program on this project, for example. Pretty cool. And yeah, personal assistants, something else that we built. I didn't go into detail here, but also we're working on that with using Python, Linux, shell commands. So interesting stuff going on here. So I'm at the end of my presentation. I hope you have some questions, and we can have a bit of a communication now. Please check out what we're doing online. We have the website, fossasia.org. We have coding contest. It's going to start in a few weeks again in the next batch. And you can find me on Twitter and GitHub and Mario Behling. They're also, like, if you type in OPN Tech, you will find information about my company in Germany. We were also hiring continuously. And yeah, I would like to say thank you again for this opportunity to join you here today. And I'd be happy to exchange with you. And yeah, if you have any doubts or questions, please ask me. Thank you very much.
Participants can unmute their microphones, and you can ask questions to Mario. Yeah, Mario, we've got a question from one of the participants.
Thank you.
Yeah. So how can students from India participate in the activities of Fossasia?
Yeah, so our activities are currently online mainly, as we don't have like live events going on. It's difficult to travel around. even when you are inside one country, yeah, there could be restrictions, and I think you are well aware about the situation, and we know of the challenges in India. So yeah, I would just say, for example, a good entry point is to go to our GitHub on github.com/FOSSAsia, and yeah, find projects, for example, programming languages or something that gets you exciting, and yeah, go through the list of issues. Check out, for example, sometimes we have a label easy issues, but what is easy is different, yeah, for different people. Like some people say, I'm a backend person, I really know databases, let me like solve an issue in this area. Somebody else say, oh no, I don't know so much about it, I like front ends. Is there a JavaScript project, for example, React.js with Suzy AI? Yeah, then people like to solve it there. So it depends. Look for what is easy for you, and join our chat channels on GitHub. Usually there's a link on the repository with, that has a specific channel attached to it that you can join and ask questions on the chat. Yeah, that's really nice. And also want to say, like we had a lot of people who went that way of like starting to contribute, then like join an internship program, for example, and later become full-time developers. Also our dear developer and friend Arif Jamal went that way. He was our lead in the last year. Arif was from Aligarh in India, and yeah, unfortunately, like it was a very sad time for us, also as Arif suddenly died here in the crisis because he didn't have oxygen available. And we actually had a call on Thursday, and this was the call where we heard like some said like, yeah, it seems Arif is even better. He was getting better, and we had already planned, maybe some said maybe he can already join again our meetings a few days later on Monday, and we had the call with him. That was our plan. We wanted to have a call with him, and then suddenly, just 3 days later after our call, we had the exchange. We had the information that Arif died suddenly, and all that happened because oxygen wasn't available for him, even though a lot of people had tried to get it, and you know, like people paid crazy amounts of money for oxygen in India, and Arif didn't get it. And yeah, so I just want to say Arif went that way. He contributed to a project, he got excited, and in the end he became a lead developer, and he was one of the top 20 contributors on GitHub in India. It is an amazing achievement. You know how many people are developing in India, and to be among the top 20, I think number 15 even, he was contributing every day. And he had a lot of job offers of like super high pays, but he said he wants to work with open source, he wants to work with people, and yeah, he was a leading person in the Fossasia community, and he's an example for us how people can contribute and collaborate with others. And it's very sad that he died. It's a huge loss for the community. There were events happening in memory of Arif in Singapore, in Europe. There's a person who was very touched, a leading developer, Debian, who planted a tree in memory of Arif in Germany. And you can find it online with information. And yeah, so that is, but we value and connect a lot with the people who are working in Fossasia, and it's not just a job, or it's not just something. I mean, sometimes, it's like the communication or something. People are really like with their heart in it, and they say, oh, why you do this, or you need to do this, or you need to be better here, right? But like in the end, it's all about collaborating. And like now we saw what it really means to have access to technology in India. Like it's actually a very simple technology to produce oxygen, but this technology wasn't available everywhere now in the crisis. And it should have been available, like the plans to build these machines to take out oxygen from the atmosphere and concentrate it and so on. It should have also all been online. It's a simple technology that should be online, that people should be able to replicate it locally. And this is the case for every technology we do. If we had known that this could happen, I think we would have started years ago to develop this kind of technology in Fossasia. But like, in my view, it doesn't matter what we do. It is important to show that we around the world can work together on open source technologies by sharing knowledge, by like finding different business models, and then people can hopefully solve their problems locally. And hopefully what happened to many Indians and to people around the world, that they don't have oxygen, they don't have ventilators, they don't have vaccines or whatever, they should be able to solve this step by step themselves. And I hope we can set examples, we can show best practices, how this can work and how people can collaborate. Yeah.
Thank you, Mario. I think we have one more question. Because I think almost all of them are behind artificial intelligence, and we have got a question about the Wisdom project at Fossasia. So we have a question on what were the plans for this Wisdom project at Fossasia, and how these users and the developers will be able to communicate with each other, because it has got completely open source recently. So
yeah. So artificial intelligence, it's a huge topic. Yeah, and like, for example, we see that a lot of companies use it, like this, for example, the Google system TensorFlow. In Fossasia, we also took over a project from Facebook. It has 8,000 stars on GitHub. So it's called a Wisdom. Yeah, so people can check it out. It's useful for manipulating, like, let's say, images, for example, or videos. Like thousands of projects depend on this Fossasia project. But like overall, right, it's challenging to work with AI. You can learn about models, you can learn how to run them and so on, but you need a lot of computing power. Yeah, it's very easy to spend like $10,000, $20,000 on Amazon cloud, AWS or somewhere, and like just like process some models, and then you realize, oh yeah, we have to change the model, and we have to change the approach, and then you have to generate again, and it costs 10,000 again. So it can cost a lot of money, and the results can be different. Yeah, I mean, it could be 60% the outcome what you want, 80%. It's percentage wise. There could be different challenges or different questions that you try to answer by using AI. But yeah, it's never the case that you can get the one right answer. Yeah, for example, when you use it for conversations, you want a computer to answer your questions. Yeah, and you use different sources like Wikipedia, Twitter, whatnot. You can never get the 100% right answer that you might get, or that you could usually get when you talk to a human. So AI can help us, but it cannot usually nowadays provide 100% like the right solutions. And I just talked about conversational, but I can also talk about things where, for example, in the US, some companies work with the police, and they say, yeah, we're going to identify any criminals or any like suspicious behavior. Yeah, and we see, for example, often they, let's say, oh yeah, there's a black person, this black person is dangerous, or there's the Indian person, yeah, this Indian person is always a taxi driver, he could be a courier for drugs or something like that, yeah. So they qualify people, even like honest people, into some categories, and then like you see that, for example, people of color, they get checked more often through police controls, or they get harassed, and it could be dangerous at some points, even as we saw innocent people even got shot in the US. I mean, it happened. These news are out there. So with AI, we need to understand and learn about it, but we also need to be clear about the limits of it. And yeah, there's so much work to be done. So that is a great time for you to get in, because we see all these issues and we hope we can solve them. And there are great ideas how to solve many of these issues, but it's not perfect. Yeah, I mean, it's not like this AI that will take over humanity or so. We are far away from that. Yeah, I mean, who knows? Like, if we are good, if we do it in a good way, hopefully robots will never harm people in that way. Some people are afraid, even like there's this news of Elon Musk say, yeah, AI, the dangers of AI. This technology is there, and it's a great opportunity now for people to get in. We have Suzy AI. It's kind of at the moment at a research project stage. It helps us to collaborate with others. We had some work together with car manufacturers like Daimler, the Mercedes car manufacturer, right? And this is also an opportunity, right? You get in a project, you learn about it, you have access to a project that usually, like, let's say Google, the Google or Amazon voice assistants, right? You can't look inside, you don't have access to them. They use AI in different levels, but you know TensorFlow, but you can't really look like how a project works in practice. This is also an advantage. So for example, Suzy.ai, we have it, and you could check out the repository and learn how it works and try things yourself. And then you have like really deep insights that you can use when you work in a company later. So many angles to AI. There are a lot of presentations and sessions on it. So I think we'll give you a few insights.
Yeah, Mario, I hope you can take one or two more questions. We have got some questions here.
Sure. If you think we have time, I'm happy to take questions.
Surely we have time. So the question is specific to the Code Heat organized by Fossasia. So how can students participate in Code Heat? Is it happening every month? So what is the procedure for students to apply for Code Heat? What is the selection procedure? Can you please brief on that?
Yeah. Mm-hmm. So basically, Code Heat contest, the thing with the Code Heat contest was it was different before the pandemic, and it's and how it is now. So yeah, it's correct that Nikhil just wrote that Code Heat is over for this year on the 1st of June 2021. Previously, we run Code Heat in a shorter period of time because, like the Code Heat winners, we always invite them to the Fossasia summit that's taking place every year in Singapore. Now in the pandemic, we decided to run it over a longer period of time, and we run it in batches of 2-month periods. And there are still winners that are currently being added in the last batch. So they will be added to the website, make a pull request. And yeah, there are a few simple steps. The first step is to sign up. And then basically to look out for a project that you're interested in. There are certain projects that are labeled Code Heat. So there's a Code Heat label, and you can click on all the Code Heat labels in each project, and then find an issue that would be suitable to be solved within the Code Heat contest. Everyone who makes 5 pull requests will definitely get a digital certificate. If you make substantial contributions in a project and you are among the top people within a 2-month period, then you have a chance to be a finalist or grand prize winners. There are different prizes, cash prizes, for example. And yeah, that's basically it. And you can then possibly join the internship program as the next step. You already know about the project, and that is possible. We are looking when to start the next project. Originally, I was thinking 1st of September, but I see there's a lot of interest now. So I will check with the team if we could possibly start it, let's say, the next one in August. We always need some time to process it. It's been difficult for us, as you know, like also said, that we lost our REAP and have difficulties everywhere, for example, like to deliver the t-shirts, to make the processing, all these things. So in the next couple of months, we hope to resolve all this and like really like also share the digital the certificates and all these things that are necessary to run a program, and then start afresh into the next program. That would be, I guess, then middle of August. People can join then, and it will be a great thing. So now is a good time to prepare for the contest, to learn about Fossasia projects, to get in, maybe solve some simple issue first, and then understand how everything works practically. So I shared here what are our best practices, but maybe you can also now get into the project itself and prepare for Keynote, so you could be a winner in the first batch of Keynote, which is then again 2-month periods, and after 2 months we announce the winners of the batch for these 2 months.
Yeah, we have got another question. Again, it's related to Keynote. Is Keynote over? Found over on June 1, 2021 in the website. Can I still sign up, or is it over?
Yeah, so if you sign up basically now, it means you will then join already into the next Keynote period. The sign-up form stays online, so basically, sorry, so 2021 actually was a contest 2020, 2021. So that period is over, and we're now starting into the next period, which is 2021, 2022. You sign up, you get all the information, and then you will automatically join into the upcoming Keynote contest.
Yeah, we've got another question. How can organizations, colleges, institutions from India be associated with Fossasia? Can the faculty get like trainings, or is it only for the students?
You mean like faculty members, for example, right?
Yeah, the question is specific to faculty members.
Yeah. So basically, yeah, we have opportunities like that. I mean, like in the past, usually what we did is we actually have local trainings. Yeah, and you have to see, for example, like if I look at the case of India, it's a huge country. Yeah, I mean, it's basically like a continent already, right? Like bigger than other areas, like more people than Europe, right? And yeah, so we cannot have trainers everywhere. We try to do some online trainings, but usually, like when it reaches a certain level, we also have like trainings that are paid. We usually do this for companies and for the like EU governments, for example. That's what we did recently. But yeah, we are open to discuss, for example, if there's a partner organization in India, let's say, and that want to like develop a curriculum for us, for faculty members, that would be interesting. So we can then like train more, let's say in India or in other parts of the world. We're definitely open to ideas, but usually our trainings are not limited to students. Yeah, also the internship program, and so it's not only for students. I know at your event there are a lot of students, so I talk a lot about the opportunities for students, but basically all of our programs are always open for everyone in general. However, most of the participants are students. For example, in India, there are so many young people, many are students, so it's a natural thing. But yeah, I think you're right. We should make also more focused trainings and workshops for faculties, and yeah, for businesses, we already work with them. So definitely something to follow up. Please get in touch with me. For example, you can like send me a message on Twitter, on GitHub, or like there's a contact form on the Fossasia website. So I'm happy to follow up on this with you if you have ideas what we can practically do together.
Mario, I think we can take one final question and wind up the session. So the question is all about the Pocket Science Lab, the hardware tool. So is it like open for all? Can students from every department collaborate with the Pocket Science Lab, or is it limited to students from particular departments like computer science or IT?
Yeah, so actually like most contributors who got on board originally were students, but they are not always students. Yeah, they progress to different levels. For example, we have one contributor, Patmal. He's from Sri Lanka, and he's now a PhD in Sweden, even like moving around. He was in Finland and elsewhere. And yeah, we have different contributors. They start often as students because that's where you explore, where you get interested. But whatever you study, whatever you do, even if you're not a student, it's a good time and it's a good opportunity to get involved. It doesn't really matter. So you can just like join the project and yeah, like, I mean, like we even had like people who study languages or something like that, and they're really interested in technology. Yeah, it's like that. Sometimes you're interested in technology, but you go to another country and you learn the language of another country. For example, recently we had a lot of people like immigrating to Germany from India, and they're all learning German. So it's not like, oh, they studied IT, so they cannot learn another language. Some of them, like, they speak incredible German, for example, I observed, and just like you know, really like high level, better than maybe some people here in Germany. And so you know, just because you study one direction, it doesn't mean you cannot be professional in another subject that you might not have studied. So even if you study something else, you could like become professional in certain technologies. And so I definitely encourage you to join, for example, the Pocket Science Lab project or other projects. It doesn't really matter what's your background.
Thank you so much, Mario. I hope this session would be really helpful to you in your way in software and hardware development. All participants are requested to kindly fill in the feedback form which is dropped in the chat.
Excellent. Then thank you very much. It was a pleasure and great honor to be here. Thank you very much for organizing this event. It's very important to connect people and new contributors and projects. So I appreciate your work very much, and I hope to stay in touch and meet you in person at one time. I hope it was useful for everyone, and I wish you all the best. And yeah, let's work together, and I hope everyone gets out of this current pandemic safely here, and yeah, we can help people around the world and really change it to a better place. So thank you very much for inviting me, and thank you very much everyone for joining. Have a good day, have all the best time, and yeah, wish you all the best. Thank you.
Thank you, Mario. Especially thank you for co-organizing the Open Source Summit. So I thank the entire team of Fossasia, you, Hong Fook, and all of the support staff of Fossasia, so for being kind enough to be the co-organizer for the Saintgits Open Source Summit. Thank you. Take care.
Thank you very much. We're doing our best. You're doing the big part of the work. We only have small contributions in my view, but like I think like it's about connecting with each other, and any contribution is important to bring us closer to our goal. So everyone be inspired by the Open Source Summit at Saintgits, and be inspired by Jacob and all the organizers who collaborate here with Fossasia as being part of it, and with the Saintgits College. And yeah, it's so good work that you are doing. Let's stay connected and have a good time here at the event. Thank you.
Thanks, Maria.
we will start our next session by 11:30.
Oleg Nanishev, Principal Engineer of CloudBees, will be delivering the next session. So we'll have a short break. We'll resume at 11:30 sharp. Thank you. Hi, Oleg, can you hear me?
Yes, I can. And you? Hello.
Yeah, Oleg, I hope you can hear me.
Yes, I can. And you?
What about now?
Oleg, I think you are not audible.
Mhm. Okay. I do not know why. Okay, thanks for confirming, Daniel. So you hear me, right?
Yeah, Oleg, you're audible, yeah. So how are you doing?
Okay, yeah, just I'm finishing a few beats, but yeah, I'm ready to present. So
yeah, I think we'll begin in another 7 minutes.
Okay.
It's scheduled for 11:30, and we have given the participants a break. So
Okay.
yeah, we'll begin exactly at 11:30 a.m. IST.
Okay, that's good.
Yeah. So how are things out there? Hope you're doing good.
More or less. So a lot of personal stuff, but yeah, nothing really blocking me. So yeah, right now I can focus on things. Just a second. Finishing a few bits. And did you finally create a chat for speakers and participants?
Yeah, no, like we weren't able to do that. We only have the Telegram channel as of now.
Oh, okay.
for the
So it's
participation.
not a yes channel, but not a group. So basically,
Yeah.
it's one-way communication.
Yeah.
Okay. Just a second. I'll switch in Chrome just in case. I had some issues with Firefox last week. So to save then sorry. Okay, I'll turn off Telegram because it's not helpful for a talk. So if you need to contact me in any case, just use WhatsApp or Telegram. I will keep it open on phone.
Yeah, sure.
Okay.
Are you able to do the screen sharing?
Yes. Just a second, I'm still fighting with bits. Yeah, I understand. Okay, do you see my screen?
Yeah, we can see.
Okay, then I will start on time. Okay, should we begin?
Yeah, sure. We will introduce you quickly, and then we can start the session.
Okay.
Welcome all. Oleg is a co-maintainer and board member in the Jenkins project. He is also a community ambassador in the CDF, the Continuous Delivery Foundation. Since 2008, he has worked in the areas of automation infrastructure and frameworks for mixed software hardware projects. Oleg writes code, maintains Jenkins and plugins, mentors contributors, and organizes community events and Google Summer of Code in the project. He is a big fan of open hardware and embedded. He has a PhD degree in hardware design and volunteers in the free and open source Silicon Foundation. Oleg works as a principal software engineer at CloudBees. We are really excited to welcome Oleg Nenashev to deliver his sessions on CI/CD tools.
Thanks for the introduction. So should we begin then? Yeah, I think. Okay. Do you see my screen?
Yeah, it's visible.
Okay, then I'll just start the presentation. Nobody shares the video anyway. Okay, let's go. Again, thanks for the introduction. Today I will talk about the evolution of open source CI/CD tools. Just to quickly summarize, I'm currently in the Continuous Delivery Foundation. I work at CloudBees, and I'm one of the contributors in the Jenkins project. Starting from July 1st, I will be in a Continuous Delivery Foundation Technical Oversight Committee. And I contribute a lot to different foundations, including, for example, inclusive naming, to-do group, and other entities organized by others. I also contribute to Open Hardware, and I have been a mentor and org admin in Google Summer of Code starting from 2016. And it was always a great experience for me. I joined Code for Cause a few times to talk about contributing to projects and Google Summer of Code, and I'm happy to be at this conference. So what we will talk today about? I will briefly talk about history of CI/CD tools, what are they, then we will talk about what's now and what's next, and we will have plenty of time for questions and answers, I hope. I have already published these slides. You can find them just on my Twitter. I posted it right before the talk, and there is bit.ly OSS Summit 2021 CI/CD. So I'll stop for a while here. You can follow the links if you want to access the slides, or maybe somebody could just post it in the chat. And yeah, before we start, just a quick disclaimer. So my talk actually represents my own opinion. It doesn't represent opinion and official position of my company, of the Continuous Delivery Foundation, or the Jenkins community. And whatever I present today will be focused on open source. I won't be talking about private source implementations. I won't be deep in different various products. For the record, CloudBees offers its own products for continuous integration, for continuous delivery, for software delivery automation. And if you're interested to know more, please ask me later after the talk. I'm not going to cover them today, except a few basic references. Okay. Let's start from basics. What are continuous integration and continuous delivery? Unfortunately, this is a topic which is not really presented at the universities at the moment. So there are some basic coverage, but at the same time, usually continuous integration and continuous delivery is perceived as a tool. So for example, you install Jenkins, you install GitLab CI, you install, you configure GitHub Actions, and you get continuous integration. But actually, it's not true. In my presentation, I will be using this logo a lot. So this logo is my attempt to just say that whatever CI/CD tool, and yeah, sorry for my math skills, this is what I was able to come up to. And yeah, in my talk, I will not reference to a particular tool. I rather want to focus on CI/CD in general. Let's take a look at a few examples. So many of you are probably familiar with cron and cron tab. Let's take a look at this flow. So you have source control management with code, POM XML, tests. You have cron, which periodically triggers git clone, then triggers build, for example, Maven clean verify if you use Java and Maven, and then sends email. A question to you, is it continuous integration or not? I'm sure everyone is muted, so I'll probably just answer a question. No, it's not continuous integration actually, and it might be implementation of continuous continuous integration, but actually it's not. Another example might be more complex. You have a system like Jenkins, GitLab again, or Azure DevOps, doesn't really matter. It takes a repository, it builds the code, it deploys to multiple environments, including test environment, production environment. Is it actually continuous integration? Is it continuous delivery or continuous deployment? And actually, the answer is also no, though it's much closer. Or, for example, this example, when you actually have automatic deploy, automatic integrations, quality assurance, automatic builds, deployments, is it continuous integration, continuous delivery, continuous deployment? And the answer is actually no as well. Even this, if you deploy to production, you can say that it's continuous deployment, might be. At the same time, it might or might not be continuous integration or continuous delivery. Why it happens? Usually CI/CD, as I said, are perceived as tools, but actually they if you take a look at materials, there are two main areas of that. Continuous integration, continuous delivery as automation, and continuous integration, continuous delivery, DevOps, and other terminologies as marketing. Both of these approaches make total sense. Both of these approaches exist and are widely used. But at the same time, continuous integration and continuous delivery is something different. It's firstly not a tool. It's not a particular marketing vision. It's a culture and its approaches. We will get to that later. But yeah, the philosophy of continuous integration is basically just integrate things as often as possible. By integrating means not only running test automation, but actually merging code to main development branches as soon as possible, so that everyone gets this continuously integrated development snapshot with all the things. So this is the real meaning of continuous integration, and it's often get forgotten. But okay, whatever continuous integration is, why do we actually need it? And yeah, I'm going to talk about how we perceive it, why do we benefit for that, and yeah, it's quite fun. If you're a manager, the answer is quite easy. So continuous integration and continuous delivery works. You spend less time on less resources as team. You get cool data and screenshots you can show in your presentation to upper management or customers. And this thing quite works. Also, currently, continuous integration, continuous delivery is a buzzword. So you cannot say that you are not doing continuous integration or delivery, but I can assure you that the most of the companies still don't. And that's a problem. So why do we actually need it? So there are common marketing things like fast issue discovery, increased product quality, increased collaboration, less time spent on merge conflicts, and of course, ensuring project transparency, because you know what you're currently delivering. And yeah, these are all valid terms, but there is one term which is actually being forgotten often. And this actually forgetting about us, common developers. So what do we want from continuous integration, continuous delivery? Actually, we want it to work. We don't want to spend much time studying it. We want a good system which would deliver on our goals, show us green checks, deploy everything. And if something breaks, roll back the system or quickly restore the state. So this is what we want. We don't really care about what a particular tool used, what a particular process used. Our goal is to deliver our products. Continuous integration and delivery is just assistance for that. It's not the center of the world. And yeah, let's talk about our CI/CD horrors. If you use Jenkins, if you use other products, if you have misconfigured system, probably you've seen a lot of them. So if you have CI, you usually get a lot of notifications through email, through various GitHub systems. There are many links being sent you over different channels, including Slack. You have to go these links, navigate, see reports, understand what happens. Often, actually, it's not your fault at all. It's infrastructure failure or maybe just a flaky test, which might be your fault, but still it's something not predictable. And yeah, in our case, we used to blame CI/CD a lot. There is a meme in our community. It's always the butler's fault. And actually, that's the case sometimes. Also, we spent a lot of time waiting. For example, you submit a pull request and then wait maybe for 1 hour, for 2, for it to build, compile, to verify it, to get all reports. And then you discover that actually things failed. It's unfortunate. It happens a lot. And if you follow Charity Measures, she did a good article about expectation that the entire CI/CD cycle should be taken, CI cycle should be taken less than 15 minutes. And I can share the link later. But actually for us as developers, waiting is a big problem and we want to avoid that. Also, we don't want to spend time and we want continuous integration and continuous delivery to help us. So for example, you have a pull request, but sometimes just merging changes takes time, like preparing change logs, fixing various minor issues. And actually it's not your job. So you do not need to review check style, call style. There are automation tools for that. There are static analysis tools for discovering common issues. There are dependency analysis checks, which can discover, for example, license issues or just vulnerabilities and dependencies you try to introduce. All of that can be automated, and all of that is job of CI/CD systems, and we want it to happen there. We also don't want to spend complex UI. So you can see the screenshot on the left. Yeah, it's not exactly CI system, but it's a delivery system. And you can see CI systems like that as well, without finger pointing. As developers, we don't want to see that. We want easy and quick feedback cycle. So for example, when we develop in GitHub, when something fails, we want to see a quick summary, what fails, why fails, and if needed, we can click on details. There are various things like, for example, GitHub Checks API or GitLab Messages, which currently make it very simple to communicate feedback right in front of developers. Also, you can send it to Slack or to whatever other chat you use and save a lot of time of developers by simplifying that. Also, as developers, we don't want to spend time on maintaining the infrastructure, because how it usually happens, you have a team and the team needs continuous integration. So you go deploy your server, then start automating things there. But effectively, you end up maintaining this thing, including applying upgrades, addressing various security fixes. And yeah, on the team level, it's quite complicated. So often continuous integration delivery happen on high levels. So there are infrastructure team, there are shared services teams in big companies, but it's their job, it's fine. It's a part of the platform. As developers, we do not really want to spend time on that. We would either take this shared service or we take SaaS so that we can focus again on our main goal, delivering our product. Also, there are many other user experience things which could be addressed by CI/CD systems. For example, when you build your product, there is a lot of various linking to happen, like linking pull requests to issues, to documentation, generating change logs, generating documentations, deploying to staging repositories, etc., etc. All of these minor integrations take a lot of time. And actually, if you could have your CI/CD system doing that, it would be great. And this is what I would expect as developer as well. So yeah, that's actually what happens these days. So not only common things, but currently CI and CD systems are about contributor experience, about developer experience or user experience. All these terms have strong relation. I prefer the term contributor experience because it allows to avoid the fact that it's only about developers. It's not. There are many different users of a system, and we want yeah, thanks for drawing. But yeah, we want to avoid using common terms. Okay, takeaways for this section. Again, continuous integration and continuous delivery are about processes, not about tools. Tools just exist to help you with implementation of your process, but they are not designed for providing a process on your own. Don't expect that you install Jenkins and you get continuous integration or continuous delivery in your project. No, you won't. Even if you install Jenkins X, Argo CD, you won't get continuous integration or continuous delivery. You will still need to adjust, and the tool is only a part of the process, though tool is a very important part of the process. Okay, my talk is actually about the evolution of CI/CD tools, so let's spend some time on that. I want to show a continuous delivery landscape. So this is a simplified version what continuous delivery foundation posts on its site. It includes some tools. It tries to categorize them, for example, pipeline orchestration, continuous integration, test automation, release automation, various configuration management, container security, etc., etc. So this diagram has one significant flaw. And this flow that it shows only a snapshot of the tools because it's basically feel free to contribute. And if you tried to build a real landscape, it would have looked something like that. So many of you may have seen the CNCF landscape. So the version on this meme is actually the old one. The new one is even worse. And this is how CI/CD landscape would look like as well if we put all the tools there. And for example, even on this image, you can see that, for example, here the category continuous integration delivery. And for example, there is Argo CD or Tecton or Jenkins, but this is just a small block. If you expand, it will be again like that with a lot of complexity, and all these landscapes simplify that a lot. So let's try to categorize the tools a bit. I distinguish three types. So firstly, it's frameworks. It's like, for example, Buildbot, Jenkins, to some extent, Tecton, Drone. They are intended to provide maximum flexibility, but they need configuration. So you take them as a framework, customize them for your needs, and probably get the most well-suited CI/CD system for your needs. Or if you cannot configure that, then you get a mess because it's hard to manage. Some manufacturers, basically tools, which again provide a lot of experience out of the box, but they can also be extended. So if there is something you don't have, you can actually get it by customizing them. And this is probably the most convenient way of using that because you're not limited. At the same time, if you know what exactly you want to get, if you know particular technology stack, if you have all the requirements, you can go about after ready-to-fly tools. So the tools which are designed for particular technology stacks, which are opinionated, but they provide experience out of the box. For example, GitLab offers Auto DevOps, there is Jenkins X with build packs, there is Argo CD, there are various Helm deployments. And these tools, again, provide great experience out of the box as long as you follow the expectations. But if you need something custom, it may be really difficult to customize and adopt that. So all these approaches make sense. All these approaches have their own use. There are no good or bad approaches. It's just something you need to keep in mind when you select your system or when you choose and compare the systems. Okay, I have a quick list of generations of CI/CD tools. Again, these generations are totally my creation. I don't pretend that it's a standardized way to classify CI/CD tools. And yeah, let's go through them. So the first generation actually started from cron. So it was created in 1976, if I recall correctly. So this is a tool which is basically just periodic scheduler, which invokes some arbitrary task. And yes, you can use it for continuous integration because you can build things, you can merge things, you can script a lot of things. Obviously, it wasn't great, and later there were tools specifically designed for continuous integration and continuous delivery. Even before continuous integration was a thing at the term, so there were tools like Cruise Control, Buildbot, there were damage control, and many other systems which are not listed. I just provide examples. But this generation was just the first basic tools which attempted to simplify work of those who do build automation. I wouldn't even call them continuous integration systems. They were rather build automation systems focused again on building, testing, and reporting. And they did the job quite well, though later there was demand in more complex systems, which would provide support for various use cases. For example, distributed builds, deployment, integration with various SCM systems on a more native level. And this is how the third generation was born. So it was approximately 2005, 2010 when these tools appeared. So, for example, Jenkins, TeamCity, there was also Team Foundation server, which currently became Azure DevOps, Bamboo, and many tools which you can still see on the market. And these tools keep evolving. There are problems with these generations. There is actually quite a lot of problems. So, for example, all these tools are rather frameworks, in my opinion, and it means that you cannot just take a tool, you need to configure them. So, for example, you need infrastructure where you deploy to set up your system, you need to configure a backend, you need to install various plugins. If you manage a team, you also need to create some samples, demos, and documentation so that the team can use this framework. And this is quite complex. It takes time, and without proper maintenance, it actually starts falling apart. So it really depends on your expertise. And this is why when I hear that, hey, we've taken Jenkins, it's difficult to use, it's complex. Maybe it's because it wasn't configured properly, or because it wasn't maintained properly. And I don't try to apologize, but actually it's a real case. And I also don't look for excuses. So these systems require maintenance, and this is a high cost of maintenance implied for these systems. But if you do it properly, you actually get a great experience and great customization. At the same time, yes, they're very complex to maintain. They require a lot of customization, there is duplication, there is a lot of complexity. And if you don't have expertise, yeah, you will have a lot of difficulties, and you may end up with spaghetti automation. Basically case when automation is horrendous mess, when you cannot find what is the job doing. There are various cross dependencies, there are various issues happening, like blocking of CI/CD pipeline, lack of executors, etc. And this is what you should be concerned of, and this is what you can avoid in any CI/CD tool of this generation, just in its experience. There is also issues for this generation, because they were created before the world as we know it now appeared. So if you do software development in 2020, 2021, you think about configuration as code, continuous delivery, DevOps, you use Docker, you use Kubernetes, you try to do everything as developers. So there is an approach called shift left. And all of that is the case, and all of that actually impacts us, because again, you cannot just take this tool and get these use cases. You either need a plugin for that, or you need to implement all these technologies on your own, and it becomes additional burden. Obviously, all these generation 3 tools evolves, but at the same time, they sometimes lack the new features, and they always have to catch up. So Jenkins, Bamboo, to some extent TeamCity, Azure DevOps, all of them evolve, and all of them became generation 4 tools by now. So they started as generation 3, but they are currently here. Other tools like Hudson, for example, they died off, and yeah, it's also quite normal. So generation 4, you can see that some familiar logos there, because many of you may have used drivers, many of you may have used GitLab CI, and yeah. This is a new generation, relatively new. It takes all experience of generation 3 into account. So it builds on the shoulders of giants with a lot of experience taken into account. It already targets new environments, new use cases, and methodologies. So they are built with continuous delivery, continuous deployment, sometimes DevOps in mind. They also focus on scalability on public clouds where we commonly deployed, and they're usually more opinionated than generation 3, because generation 3 was a problem for everyone because they were frameworks. And there was a decision made that, okay, if you don't use framework, if we provide customized experience, we will be able to compete against 3rd generation. And this is what the tools did. So usually they're much more opinionated. At the same time, they still have to catch up with new features, because Jenkins and others, they have hundreds of plugins for different use cases. And if you develop a new tool to provide similar functionality, you need to spend a lot of time. I mean, millions of man-hours to compete with Jenkins. And well, it's a question whether you need to catch up or whether you do something else. But yeah, this is a question for all these generations. And for many, they're too opinionated because, again, they're less flexible than frameworks like Jenkins. So the first generation is mostly designed for cloud native deployments. It doesn't mean that it's cloud native in CNCF definitions. It means that they get deployed in various clouds. So private clouds, public clouds, software as a service, all of that gets there. And the main point that we as developers, again, do not want to manage our own infrastructure. And it was one of key differentiators when these tools appeared. Nowadays, all tools of previous generations like Jenkins, again, TeamCity, they all support cloud deployments as well. So it's not a differentiator anymore, but this is how first generation appeared. Another differentiator, again, for first generation is something as code. So for example, configuration, documentation, pipeline, it's a part of continuous integration, it's a part of DevOps vision. The main point is that you store everything along with project, you version changes, and you test changes along with the project. In CI/CD systems, it usually means two parts. Firstly, like quite legacy part, infrastructure as code. So if you're familiar with Puppet, Ansible, etc., or modern things like Helm, like you just deploy your system and manage this code. It's great, but again, it's for administrators. It's not for us as end users. For us, it's more important to have automation as code, or how I call it, pipeline as code. What it means is that you can define your jobs and automation. So you can define your entire pipeline as code. You can manage it as code. You can store it in your repository and evolve along with project. And this is what, as developers, we get in generation 4 tools and in many tools which adopt this generation, like Jenkins. So pipelines. Currently, pipelines are really everywhere. It's not just a buzzword, though it may mean completely different things. And the main idea for pipelines and pipeline as code is that everything is defined as code and you can use it. At the same time, everything defined as code doesn't mean a particular technology. So for example, it may be imperative or declarative definition. For imperative, it can be programming languages, like you can write things in Java, in Bash, you can write things in various DSLs like Kotlin DSL or Groovy DSL in Jenkins. There are also declarative definitions where you can, again, say what you want to get, but not how to implement that. There are various DSLs for that. There are also modeling languages. For example, yeah, you can write a lot of things in YAML these days, or you can write things in various XAML for more legacy systems. But yeah, these days is mostly about YAML, and all of us are YAML engineers. So these declarative definitions are actually easy to use because you don't focus on implementation. You leave implementation to your platform, to your automation system, to your CI/CD system. You just say what you want to get. One of examples, probably not the best examples, is Appear, where it uses YAML definition, where you say that, hey, I am going to build this project, I'm going to use Visual Studio, I'm going to build on any CPU and configuration. And as a part of this build, I want to build this project. And after the build, I want to package NuGet and publish test results. So this is what it says. It doesn't say how to implement that, in which order, what to invoke, which environment to set, how to configure everything. Again, it's up to CI/CD system to provide support for this environment. Yeah, these implementations are really simple. There are many implementations. If you want, I can show it things like Argo CD, Jenkins, or whatever. But yeah, the principle is that they are declarative, they're easy, but at the same time, they have limitations because they're not full programming language. You say to the system that you want to get something, but if there is no way to describe what you want to get, you're in trouble. So for example, if you use Jenkins pipeline, if you want to parallelize tests, etc., there is no notion how to parallelize tests right now in Jenkins pipeline DSL. And if you want to do that, you will have to spend a lot of time scripting it by different plugins or via script pipeline. And this is actually a point. Imperative definitions, they're much more universal and flexible. They may be Turing complete, they might not be Turing complete, but the main thing is that you can actually develop what you need. So for example, there is Kotlin DSL, and in this Kotlin DSL, you say stay by step what you want to build. This is probably not the best example again, because this definition is rather declarative, because here you can say that there are particular steps, particular trigger, particular cleanup logic. So yeah, it's probably borderline between declarative and imperative, but here's fully uh, fully scripted imperative example. So Jenkins uses Groovy DSL as one of the engines. There is scripted pipeline where you can just write in Groovy, almost in Groovy, what you want to get. And here, for example, I said that I will take a node called Docker. I will check out the CM. Then I will launch particular step to retrieve image tag. Then I will build something with Maven, invoke shell script with makefile, and then I will run a build container. So this is a fully imperative example. I tell my CI/CD system what to do step by step, and it's responsible to perform it as is. It's also a good approach. I can write whatever I want, but it's more complex to maintain. And if you have no expertise with that, at some point you may get into issues. Because, for example, here there is assumption that there is Docker node. What does it exactly mean? You need to know. You probably need to read some documentation, because it may mean completely different things depending on the instance you use. And in modern systems, it's actually not a hard choice between imperative or declarative. Many systems like Jenkins, TeamCity, they support different ways of definition, what's declarative and scripted, and you have freedom of choice what you take. Other systems don't have such freedom of choice, and then you have, for example, put whole imperative definitions in scripted steps, because basically every system allows to invoke shell script, and you can use shell, because shell, like bash, they're imperative. So you can put your imperative logic there, though it's quite complicated. So this was the first generation, and now there is generation 5, with emerging, which again has a lot of various phases. What it means, firstly, it learns from experiences of previous generations as before. So it learned from experience of generation 3, where tools were too flexible and were difficult to use. And it also learns from experience of generation 4, when tools were too opinionated. And what the generation 5 does, firstly, it remains opinionated, but instead of creating a system for every need, it focuses on specialization. So there are tools which address particular cases, but do it well. So if you're familiar with Unix philosophy, it's like that. So there is a command like, it's a bad example, for example, command like ls, which shows you directories, etc., and it does it well. There is a command make a directory. Again, it does a particular function, does it well with a lot of options, but just a single function. And generation 5 evolves in such way as well. So there are many tools that are highly specialized on different use cases that are still customizable. I made a mistake, so Spinnaker doesn't belong to generation 5, it's generation 4. I just copy pasted it occasionally here. But yeah, there are tools which do not really do CI/CD pipelines. For example, Artilius is focused on configuration management. Argo is solely focused on continuous delivery. It doesn't really do continuous integration well. There is Screwdriver, which is mostly focused on CD for mobiles. There are various tools which are focused on specific use cases. There is also GitHub Actions. GitHub Actions is a more complicated topic because it's like a system, not a single tool. But again, I think that GitHub Actions belongs to generation 5 because it was built in a customizable and extensible way, but designed for use cases when you can build highly specialized tools as container steps or as applications. And yeah, Spinnaker is generation 4. What else applies to these generations? So firstly, they are mostly cloud native. Almost all tools are cloud native or intends to be cloud native. All of them are quite small. They adopt new technologies. They highly integrate with various foundations like Continuous Delivery Foundation, Cloud Native Computing Foundation. So, and they get used quite a lot. But again, they do not provide full CI/CD system. They focus on simple use cases. And then there are tools like, again, Spinnaker from generation 4, or for example, OpenShift, which integrate these tools and build a proper CI/CD system out of them for you. Okay, we briefly talk about generations. Let's take a look about what happens now. And again, I'll talk about my vision. This vision might be different from reality. If you're interested, you can take a look at different blog posts. For example, the Continuous Delivery Foundation has posted trends will define CI/CD in 2021. You can refer to these materials. I will just talk briefly about what's my vision. So firstly, battle of generations will continue, and it continues. So generation 3 and 4, they actually evolve. So things like Jenkins evolve a lot. They adopt configuration as code, cloud native deployments, various serverless options, deployments to public clouds, and they have to evolve because otherwise they will die. So for example, Hudson has been proclaimed officially dead in 2018. And this is what happens with tools which are unable to evolve due to lack of resources, lack of contributions. And the generation 5 keeps emerging. It's here to stay. It will experience the same issues like generations 3 or 4, because yeah, it doesn't provide all the features needed. At the same time, it doesn't intend to provide them. It focuses on providing small functions and well, and then it leaves opportunities to other generation 3 or 4 tools to actually glue them together into the CI/CD system. And this is a quite good approach. For generation 3 and 4 tools, there is a problem with actually making significant change if they want to evolve and if they want to continue living. So Koseki in 2018 released a blog post called Shifting Gears for Jenkins, but it actually applies to all other projects. If tools want to evolve, at some point they get into a situation like that. So they on a local optimum, they're really, really good for their use cases. But if they want to become better, they have to pass through significant change. And this is what many tools in the current state at the moment. Jenkins has mostly passed it by adopting new technologies, but still there is this huge gap, and there is this gap which always appears. So we passed from generation 3 to generation 4, and now we will have to pass through generation 5 like that, for example, in the Jenkins community. Also, another trend is that continuous integration and continuous delivery tools, and especially pipeline engines, they become commodity. So it's no longer good to provide a good pipeline. This is unexpected. This is what all systems do. And as a vendor, you should actually provide multiple engines, and you want to use multiple engines. For example, Tone, Jenkins, Jenkins File Runner, these are pipeline engines to some extent. Jenkins can be used as orchestrator as well, but it also can also be used as an engine. And these tools, they provide pipeline execution. Other tools, which are based here, they actually choose which engine to use for their needs. So they can integrate with multiple engines. For example, Jenkins X3 supports 3 engines. There are other tools like Spinnaker, which again do not do engines on their own. They integrate with others. And this is approach which helps. But these engines, yeah, they're reusable, they're portable, and they should become more like that in the future. Another nowadays trends that focus shifts to modern environments and use cases. So everyone wants to have cloud native environments. Everyone wants to deploy it to public clouds like AWS, Azure, Google Cloud. You want to have container environments, the Kubernetes and Docker. And actually, specifically, Kubernetes Kubernetes becomes everything these days. And this is what CI/CD tools have to take into account. Being cloud native is not easy. Being cloud native in real actually implies significant architecture changes, and many tools involved in this direction, especially for generation 5. So they want to provide the best service for each need. They want to have infinite scalability. At the same time, they want to be pay per use. So when you do not use the service, it's basically shut down mostly. At the same time, you want these tools to be easy to use, easy to maintain, easy to develop. And sometimes these bodies contradict with the first statements. And this is a problem which any project and any vendor have to resolve when they go to cloud native environment. One of examples for cloud native pipeline engines and frameworks is Tecton. So Tecton is also a project of the Continuous Delivery Foundation. It's designed for building, testing, and deploying things, and it's solely focused on Kubernetes environments and cloud native environments. So it lives in containers, in custom resource definitions of Kubernetes. Every step is implemented as a separate container with shared workspace. And you actually can extend the system by providing containers. So it doesn't longer matter what the tool is written in. So for example, Tecton is written in Golang. But for example, the step you invoke can be written in Java, in Bash, in Python, as long as it's packaged as a container, as long as it follows the common interface. It doesn't matter which tool you use and how it's implemented. And it's the advantage of modern generation systems because they become more and more agnostic. And Tecton is just a good example of that, but it's not the single example. GitHub Actions actually operates like that. There are other tools like OpenFAS, which again provide this platform, which is quite customizable and flexible. Another point is that the tools focus more and more on developer experience because developer experience is what you need to be successful in the market to compete against other tools. And right now it's no longer a blue ocean, it's a red ocean when a lot of tools compete. And it means that you cannot just take Jenkins and Kubernetes and create a new product. There is already Jenkins and Kubernetes. In order to provide a new product, a new project, you need to provide significant value differentiation. So for example, for Jenkins X, when it was created in 1.x, it was about providing out-of-the-box experience for users, and it's a common attack vector. So they're opinionated, they provide, for example, build packs for continuous delivery of various common technology stacks like Spring applications. They provide various modern technologies like GitOps. They provide tools out of the box, so they're not a CI/CD system. No, they're just CI/CD server. The entire system, they have repositories, they have monitoring tools embedded, etc., etc. And they provide features like, for example, IDE integration, support for development environments, so that users can and developers can easily leverage advantages of these systems. Last but not least, tools nowadays try to become software as a service. Or at least it's high demand because many vendors actually switch to software as a service. Many users adopt software as a service, so they don't have to maintain systems on their own. They do not want to spend resources on that. Do not want to spend resources on upgrading, installing plugins, troubleshooting various dependency issues, or resolving security issues. They want to just get SaaS and pay for that because again, cost of ownership may be much lower with that. And actually, SaaS these days doesn't longer block you from using local resources. So there are things like GitHub Runner, GitLab Runner. For example, when CloudBees had Devon Cloud, we also supported using local agents with SaaS version of Jenkins. And this is a common approach because now you can combine the best of two worlds. Also, if you're concerned about going to full SaaS, there are internal SaaS platforms available nowadays. So for example, you can take GitHub, GitLab, deploy locally and build a social coding platform for your system, adopt inner source, for example, and use the same principle as SaaS. It's just your internal team maintaining SaaS, but most of the teams use it as a service, whether it's internal or not. And this is what happens. And this is what you need to adapt to if you use CI/CD. But yeah, we talked about tools a lot, and let me return back about culture, because continuous integration, continuous delivery are actually about culture, and culture also changes how we approach development. Just a second. Yeah, a few points. So you have seen this meme. Everything is about developers. I don't think it's true. Everything is about contributors, whether they are developers, marketing people, sales, professional services, support. It doesn't really matter. These roles become quite unified. And these roles communicate with each other more and more because there are methodologies like DevOps, like inner source, and they actually presume that you have collaboration in between your teams, and yeah, that changed. So for example, for DevOps, cultural impact, there is shift left. So developers take control of the system, including delivery pipelines, and delivery environments. Also, they focus on developer experience. Tools evolve syntax. The imperative syntax is needed only for advanced users nowadays. And the most of users actually get things out of the box. And sometimes you just need to put one line of code to get your entire pipeline running, or maybe no lines at all. Also, there is a huge focus on interoperability because tools have to integrate with each other, especially fifth generation, because they don't resolve CI/CD story on their own. You need multiple tools in the equation, and these tools have to collaborate. And yeah, it happens a lot these days. And another thing which is important is that being open source becomes an advantage because developers want to have full control. And what's best than open source, because you can just take something, patch something, contribute if needed, and it defines a shift towards open source approaches. And almost all tools in fifth generation are actually open source. Like, for example, Argo CD, Tekton, or they provide open source ecosystem like GitHub Actions, because otherwise you cannot really compete on this market anymore. Another methodology and culture which evolves is inner source. It's less popular than DevOps, but it's, in my opinion, not less important. And the idea that open source culture and approaches get adopted in companies, collaboration becomes a key. So like you create in community, you create issues, review pull requests together, engage with communities. The same happens inside the companies. And that's why internal collaboration platforms and internal CI/CD platforms become critical, because they again provide support for these methodologies. They don't implement culture on their own, but they provide great support for that. And if you are not familiar with inner source, I highly recommend taking a look at that. There is an organization, an initiative called Inner Source Commons. There are other organizations like To-Do Group, which focuses rather on open source programs, but open source programs and inner source are quite related with each other. So you can take a look, and this is what will actually be popular a lot in the coming years. So it's not about DevOps. Take a look at that. Okay, I'm slowly running out of time, so I'll quickly talk about what's next, and actually it won't take a lot of time. So you may ask, do we need a new tool? Do we need a generation 6? Do we need a new tool in generation 5? And this is a very good question, and I think that the answer is rather no. You don't need new tools except cases when you want to address something new. You don't need to create a new automation framework anymore. You don't need to create new pipeline engine, because there is a lot of tools available on the market. And if you need to create something, you have to have really strong reasons for that. Instead of that, it's better to collaborate and better integrate with each other. And this is why, for example, the Continuous Delivery Foundation exists, and the Continuous Delivery Foundation, which I represent today, is here to help. So basically, Continuous Delivery Foundation was created as a neutral home for next generation of continuous delivery collaboration. So what it means, it's not focused on particular vendor, it's not focused on particular tool. It actually integrates various tools, projects of different generations, and encourages these generations to collaborate between each other, and encourages interoperability between projects. So what the Continuous Delivery Foundation does, it fosters the ecosystem, it promotes collaboration, it launches various outreach programs, advocates for interoperability and other approaches. And this is how the foundation works. The Continuous Delivery Foundation is actually a branch of the Linux Foundation, like many other foundations these days. Yeah, it includes multiple projects. So currently it's Jenkins, Jenkins X, Spinnaker, Tecton, Screwdriver, Artilius. So you can see that it's basically from generation 3 to generation 5 at the moment. Also, there are tools which applied to become a member of Foundation. For example, Shipwright, which is focused on building Docker images, and the Continuous Delivery Foundation provides venue for these tools to collaborate, and there are multiple venues for that. For example, there is interoperability SIG, special interest group, which is solely focused on how the two collaborate with each other and how you build this ecosystem consisting of various tools, how to you integrate them, how you create tools in a way that they can be integrated in wider systems. And yeah, this is a main work, and this is a great work I see in the foundation. And once I join the technical oversight committee in just a few days, interoperability will become my main focus. Also, there is spin-off of interoperability SIG focused on events. So this events is a way to actually talk for system to talk to each other, and it's a foundation for interoperability. So the SIG works on various platforms. It's one of promoters of cloud events. It's one of promoters of Eiffel. And for example, in Jenkins, we currently have a Google Summer of Code project focused on adoption of cloud events in Jenkins. And yeah, this project is going quite well at the moment. And we try to facilitate such initiatives. In the CDF, there are also other special interest groups which facilitate the collaboration between projects. All of them are about that. So security, define common security practices and the recommendations. MLOps is focused on machine learning and artificial intelligence. Best practices just provides information to users, how to actually use CI/CD, how to build pipelines. And there are various project-specific special interest groups. For example, in Jenkins, we have configuration as code, cloud native special interest group, and we have many projects. All of that operates under the umbrella of Continuous Delivery Foundation and works quite well. There are also technical entities like Technical Oversight Committee, which I will join, which focuses on technical direction. There is Outreach Committee, which facilitates joint marketing, runs ambassador program. There is Governing Board, which focuses on budget, finance, on supporting projects with infrastructure, because it's quite expensive, and we are happy that Continuous Delivery Foundation sponsors the Jenkins project, for example. Okay, I have a few minutes left. And yeah, what's left? So key takeaways for you. So firstly, automation is really eating the world, whether it's continuous integration, continuous delivery, DevOps. It's what's there to stay, and it's what you have to be prepared to if you want to be successful on the current market as an engineer or as a manager. Continuous integration is an industry standard at the moment, and continuous delivery is also an industry standard, because without them, you cannot compete on the market anymore. But both CI/CD are not just about tools; they're actually about culture, about methodologies, about practices, and you have to keep that in mind. At the same time, tools are there, tools provide support, and they keep evolving. So there is a lot of things, there is a lot of exciting changes, and please take a look at the market. And yeah, the Continuous Delivery Foundation is one of the entities which actually can help you with the evolution. What you can do after this talk. So you can take any open source CI or CD tool on the market, whatever is your preference, whatever is your interest, and try automating your project. You might have a lot of side projects, university projects, some of them have no automation, and it would be a good use case for you to just try it out, try to create continuous integration pipeline, maybe continuous delivery pipeline, and study these tools. And it's also a great time to contribute, because everything is about open source, and all tools I was presenting today are open source or have open source ecosystem. So you can just start contributing to the foundations, like join special interest groups, study from there, spread the word, maybe join ambassador platform, contribute to the landscape, and contribute to various CI/CD projects. For example, in Jenkins, we always look for contributors, whether you are interested in coding, documentation, testing, localizations, or you want to help with running events, create cool design. We are looking for any kinds of contributions, and if you're interested, Jenkins.io participate. This is a landing for all kinds of contributions, and feel free to reach out to me. I will be happy to help and provide detailed guidelines. If you have any questions, so there is GitHub, there is my Twitter account, there is my email. You can find me on LinkedIn. Please don't hesitate to reach out and ask questions, and I will be happy to answer them. And I believe that I have a few minutes left. So yeah, if you have any questions in the chat, I will be happy to answer them. So are there any questions?
Yeah, participants can unmute the microphone and you can ask questions to Oleg. You can also drop your questions through the chat window.
Okay.
Yeah, I just wanted to know if the participants, the registered participants will be able to get a copy of the presentation, the very knowledgeable presentation we just received.
I can share it right now. Actually, I shared the link in the beginning of the presentation, but I put it into the chat. So all my presentations are open. You can take them, view them during the talk, and also they are licensed under Creative Commons. So yeah, you can just take everything from there. Regarding my email, there is a question. I would actually recommend to use my personal email. But yeah, full disclaimer, I'm not a contact in terms of community support. If you have questions, please use public channels. So for example, yeah, I'll share my screen. Yeah, in open source, the best practice is to actually reach out to the community in public channels. So for example, in Jenkins, we have a lot of mailing lists, like these ones, Jenkins users, Jenkins developers, Jenkins board, or there are, for example, chats, which you can use. For example, if you're a fan of Gitter, IRC, or Slack, fortunately or not, we have channels everywhere at the moment. You can ask in these channels, or we have recently launched the community Jenkins.io. It's a discourse forum, again, for users and developers, which you can join and ask questions. So if you want to ask me about something, most likely you want to ask on these platforms, and I will be happy to answer there. Asking in private, it's a rather bad practice in the community. I hope it answers the question. But yeah, I shared my email just in case. And again, all the slides are available, so you can use and reuse them if needed. And feel free to reach out to me if there are any questions. Okay. Anything else?
Are there any more questions from the participants?
I guess not. So again, thanks everyone. You can try CI/CD tools. You can contribute, and you're welcome to contribute. And yeah, thanks a lot for your time. Feel free to reach out to me afterwards. I will be happy to provide any kinds of assistance. Okay. I'll stop sharing my screen.
Yeah, Oleg, I think you've got one question.
Thanks, Oleg. Thank you for that informative session. The most important phase where we have struggled recently was actually the lack of official plugins for this Jenkins integrations, especially for serverless deployment. So what is that kind of hack for that?
Okay, so yeah, serverless deployments is an interesting topic for sure. So if you go to plugins Jenkins.io, you can see that there are 1,800 plugins for various use cases. At the same time, for deployment, there are, let's say, for example, if you look for Helm, well, you got a lot of the things, but definitely not Helm plugins, I guess. And this is what you're asking for, right? So plugins for common deployment technologies these days. Why it happens? Firstly, these plugins have great CLI tools, and you rarely need something in the web interface, you rarely need a plugin. And instead of that, the approach in Jenkins is to use actually pipeline libraries. So pipeline libraries is a way to actually extend Jenkins with particular functionality. And currently you can use pipeline libraries on par with plugins. And many new development actually happens through pipeline libraries because it's much more convenient. For example, I can show you Jenkins Infra, Jenkins IO. So for example, in Jenkins, we have our own pipeline library. Because we built our components with Jenkins, of course. And here we have a pipeline library, which is quite big, but it provides automation for our needs. And here, for example, in infrastructure, wrong button. So in variables, for example, we can you can see that there are multiple various methods provided. And for example, we have a method, for example, for building and publishing Docker image. So we do build and deployment in the same step with annotations. You can see that we do it, for example, here in Kubernetes. So we provision an agent which does the build. And after that, we just implement this builder. We put the environment, we put credentials for deployment, and then we finally do some automatic semantic versioning, linting, building, deployment, etc., etc. So what I'm trying to say, in Jenkins and in other tools, it became more common to use these approaches. There are public pipeline libraries which you can reuse. For example, I believe that Visa or MasterCard, one of finance companies, they published a library for managing Helm. Here, we rather use Docker, but at the same time, you can see that there is a lot of integrations. For example, we deploy also to GitHub releases from this pipeline, etc. And it became more common to just write these pipelines than to create plugins.
Awesome. So it can be integrated with containers and Kubernetes, right?
Yeah, it can be. There are plugins for that. There are just not so many plugins as you may expect, because naturally people tend to use automation scripts instead of plugins. And for example, these scripts, you can reuse it in your environment if you want. It's flexible enough. And there are other pipeline libraries like that, which again, extensible and can be reused. So it's basically the same as plugin.
Awesome. Thank you.
Mm-hmm. Okay. Anything else?
Do we have any more questions from the audience?
Thanks, everyone.
Thank you so much, Oleg, for the wonderful session. Participants are requested to fill the feedback form in the chat box.
Okay. And yeah, if you have any questions, please feel free to follow up. I'll probably create a thread in Discourse, so ping me in the chat and I will send the link.
Thank you, Oleg. That was a really remarkable session. So we've got good feedback for the session. So it was really amazing to have you for the Open Source Summit India 2021.
Yeah, and see you at the fireside chat in a few days.
Yeah, sure.
And yeah, I'll still hang around and we'll probably participate in
For the
talks.
information of the participants, Oleg will also be available for an Ask Me Anything fireside chat on Friday, 10:15 a.m. IST. So he is very active with the activities of the Open Source Summit, and he has been a great, he's been very great with his activities for the Open Source Summit and a real motivation too. So thanks, Oleg. We look forward to meeting you on Friday.
Yeah. Thank you too. So we just wait for the next session, which starts in 10 minutes, I believe, right?
Yeah, no, the next session will be starting at 1:30 p.m. IST. So we'll be having a lunch break here in India. So we'll start the next session after an hour, 1:30 p.m. We have Alessandro Volpato, who is a biologist and open source contributor. So feel free to be attending this session. We look forward. I know that you have reserved the entire day to attending this session. Thank
I
you.
will happy to join, and I will use an opportunity to have a breakfast break.
Yeah, sure.
Thanks again for organizing this event, because the agenda is really great. It's very diverse. There are many open source contributors from different communities, completely different angles to be presented. So I really enjoyed this event, and I'm looking forward to participate.
Thanks, Eric. Take care. Bye.
Thank you too.
Now it's time to wind up our forenoon session, and you are requested to be back at 1:30 p.m. for the next session. Thank you all. See you in the next session.
Hi, Alessandro. Can you hear me? Alessandro? Alessandro, am I audible to you? Yeah, am I audible now, Alessandro? Yeah. Yeah, can you hear me? Can you hear me?
Hello, hello. Okay, at least you can hear me.
Yeah, can you hear me? I think we've got some connection issues at Alessandro's side. We can hear you, but the other way got some problems, I think. Can you hear me? Hello.
Can you hear me? Hello?
Hello, hello, Jacob.
Yeah, Alessandro, can you just try logging out and joining once again?
Yes, I will do so because I'm trying to actually to hear the sound because
I can actually hear you. Yeah.
You
session. Can you unmute and try? Am I audible?
Hello, everybody.
Yeah, hello.
Yes, I would like to upload a PowerPoint.
So before that, I'll just give an introduction, then we'll start. Is it okay? Just wait for me.
So,
good afternoon, everyone. So we are getting into the day 1, session 2. So today we have the guest speaker, Alessandro Volpato. He is a biologist and advocate in open source. And he design innovate tools to support a collaborative research environment and facilitate the learning process in life science in and outside of universities. He believes that involving citizens in the decision-making process contribute to the design a future that can better fit the needs of single individuals. Universal access to the education is the key to empowering individuals to participate in the process. Hence, he fosters the critical discussions and inspires and others to forward their own inquiries. As a biologist, he organized workshops like the mushroom cultivation course connected to the mind, the fungi, and is involved in explorations of innovation or opportunities at the intersections of technologies and biology at the companies involved in information technology. So I welcome you, sir. Session is yours. Thank you.
hello, everybody. It's a pleasure for me to talk at Saintgits. And Jakob, one question: how do I share my PowerPoint?
Yeah, you have a share screen button right at the bottom. You
Yeah.
can see a green button. You can click on that.
Yeah. So okay, I will.
So yeah, you can share the desktop. It will be showing an option: desktop, whiteboard. You can share the desktop, and then you can start the presentation.
Yes.
Yeah, we can see.
You can see. One
Yeah.
second, because I need to wait. Okay, perfect. So welcome everybody. Today I'm gonna introduce you to open source concepts in life science, do-it-yourself biology and innovation. Hello, I'm Alessandro Volpato, and as Jakob said, I'm involved into bringing the people into individuals which want to propose new solution into the innovation process and let them to give their impulses and provide knowledge to how to forward in our with our decision in our society, and how to take how to bring solutions that can impact our world and benefit everybody. As Jakob was saying, yes, I give also workshop and teach people how to cultivate mushroom, produce mushroom-based materials to support this sustainability movement and to reduce the human impact on the environment. And also research on lab automation and how to make research together with open source devices. So what happened? In 2016, started my journey in this in this do-it-yourself biology environment, where I put my initiative into action and proposed my own solution to the world. I'm based in Berlin, and I was at an event, which is the Science Hack Day, where scientists, programmers, artists, designers come together to hack for 1 weekend on science. And I saw that there was there were biologists that were using Arduino and open source software and programming and making their own machines. And this made me wonder what's going on with these biologists that use the open source hardware and software tools to make something. Let's explore a little bit more of what's going on. Well, in this community, you are well aware, because of my biologist background, for me, it was really hard in the beginning to understand what hardware and software were. And so, well, I studied for 1 year bioinformatics, and so I got deeper into software. And then I started prototyping with hardware and checking what's possible to do. And of course, the same, I wanted to apply the same to biology, but this will come later on. And what I liked was the values behind open source hardware and software, which was the ability to use the products that you were seeing, to access the design file, the code, and to study how was it done, to modify it for your own purposes, and then to give it away simply to other people, to do what you were doing, to use your solution, and to share more of what was possible to do. So we have hardware and software, which is really easy to understand. And in biology, we have wetware, so which is something that is a little bit in contrast with what you know as hardware and software, because, well, hardware, it's really easy to understand what it is, because it's hard. It's the very construction element that you use to build computers, machines, and everything. While software, it's also possible to grasp, because it's the code that is running all the electrical components that are assembled, and you have an effect. You have a machine that is running. As wetware, we intend all the wet stuff, we intend it as liquid form, because as biologists, you study life as it is, and you work with a lot of liquids. So you can imagine in a biology lab, the biologists simply pipette a lot of tiny droplets from one tube to another one. They merge droplets, they heat droplets, they cool down droplets, they wait that things grow into this liquid. And this is what we call wetware. So all these liquids that contain information about life, and also enable biochemical processes. So all the reagents, when you add something that makes something happen in a tube, then for us is wetware. By the way, if you have questions, please don't hesitate to ask them. I don't see the chat, so please notice me. Yes, so wetware in life sciences. So life sciences is the new name that encompasses all these fields of studies that deal with biology and with life. So medicine, for example, or food science, they are all fields that are related to science, to life science and to wetware. For example of wetware are also from the left to the right. You see a sample of Candida albicans, so which is a yeast that infects yes, human bodies. And this for us is wetware, because it's the unit, the cell unit that contains the life instruction. So contains the DNA, which is the blueprint, the instruction manual to build an organism and to make it work. If you want to say it in a more engineering way, is the software or the code that has to be run to produce an organism and to let him live. We have here the test tubes in clamps. So in the test tubes, usually you have reagents, and that's also wetware. It's exactly these molecular compounds that make things happen in the real world. And then on the right, you can see how the DNA is done. There is open source software, which is called PyMol, which is used to visualize such complex molecule and visualize, give you an insight about the complexity of the wetware. And once, of course, you have wetware, you have people that are really enthusiastic in studying this wetware. Usually research is done in academia or companies to make products. And therefore, individuals can just apply for jobs and have very little to say about in which direction the research should go. So some individuals started to research on their own initiative. And that was cool because they could study problems related to their lives and propose solutions that are really user-centric. And their goal was is to use the solution that they are researching on. Of course, then having individuals researching, usually these individuals have all the interest to share their knowledge, so they build communities, small organization, and what happens is that you apply the same methods that are used in the university and research on the real environment. What can you do, for example? So in 15 years ago, there was a big oil spill in the Gulf of Mexico. And for example, an organization came together, which was called Public Lab, and they put together a method to test oil in water. And it was about spectroscopy. And this community led the whole bigger community into this, into analyzing the water and keeping calling the authorities to clean up the oil spill, and those relieving and improving the the recovery of the environment. This is just one small example about how do you deal with wetware and biology, but of course later will come more. So let's go back at my example at the Science Hack Day. I met here this guy who was also into environmental biology, and he prototyped a machine with hardware and software, which was able to control the evolution of yeast. So what do you see here in this big groove of cables and machines and tubes and liquids flowing everywhere? This is simply the hardware and the software that were used to control a machine which would put evolutionary pressure to drive yeast to digest some plastic. So the goal of this machine is simply to digest the plastic in the environment and to let yeast, a fungus, a mushroom, it's a type of mushroom, a really tiny microbe, do the job. And for this, he was training this tiny organism to eat plastic. And how does he do that? Simply, he was starving the organism until the point that he was learning to digest the plastic, and then he feed it more to let him grow, and alternating these cycles of starving and so of having nutrients and then having just plastic as food, he managed to push this organism to digest plastic. So what are the motivation behind these actions? Usually individuals want to try to solve problems that are close to them. In Europe, for example, we really praise environment, and we try to produce new solutions to tackle this issue and to push on sustainability. But also other fields are medicine, food, and we want we are all together in this movement to push together for a better future, to have higher standards for products. And because this environment is non-competitive, because we as individuals want to really to push forward and to have a better future. This is how we come together and share the same values of the open source hardware and software communities. So what do? We need a laboratory, and what has happened is that the community or members of the community, for example, Gaudi Labs, reproduce a set of the basic tools used in a lab and open source them. So exactly like for hardware and software. And with these basic tools, you can learn how to work in a biology lab. You can see just the basic things: a microscope, some tube holders, there is a spectrometer, a device to analyze light, a PCR machine, which is a DNA copy machine, quickly said. And this is the basic tools that you use in biology to experiment with life and to evince information that then you can use to realize your own solutions. What are other crazy examples of do-it-yourself biology projects? Well, on the left, you can see the FlyPy, which is a fluorescence microscope. These are very advanced projects, because this is what is used actually in a real research biology lab. And it's possible simply to 3D print your parts. And this is what you use, and what I also use in my research practices, to see into the cells. So the cells are the bricks, the units of the human body, the functional units. And there are diseases that affect the cell, and you want to check exactly what's going on into the cell. And therefore, you tag or mark some components of the cell, and you can make them fluorescence. So fluorescence means it glows in green, in blue, or red. And then you have a camera that is able to see just one color, and you can see what's going on in your cell. And in this way, detect diseases usually. Or on the right, you see another project of mine, which is done in collaboration with Fossasia, the community that is developing also the Pocket Science Lab, which is also an open source microcontroller on top of which you can build your own laboratory. And in this project, we are building an open source spectrometer, which is a device that is used in a laboratory to check what's inside a sample and how much of it there is. It's a really important tool, and it's a really difficult one because it involves a lot of optical components, and is a field that is far from the usual hardware, open source hardware and software community, because it's not the field of expertise of the people who studied in this area. This is a challenge actually, because because usually the people who develop in the open source hardware and software communities, they have a job and they studied in their direction, and they have a job in that direction, so they are specialists. But in the moment where you have other fields of expertise, the challenge becomes transdisciplinary, we call it. And this is something that brings a lot of value, because you can reach further ends of the user experience and really solve issues that are far from you, and you can reach people that have really specific issues, and you can include this field of expertise like biology into open source hardware or software. And this is what's coming next in the open source environment. What are the real life issue or the real life opportunities that do-it-yourself biology projects bring? So I will tell you about Open Insulin. So there are two projects here that I will tell you about: the Open Insulin one and the 4 Thieves Vinegar Collective. The Open Insulin is a project US-based, which is trying to reproduce insulin in an open source setup. So this is a geographical specific issue, because in that country there are specific patents on insulin. So insulin is the molecule that in our body regulates the sugar in our blood, and people with diabetes have to take regularly insulin to be able to be healthy. But of course, because of these patents, it's for them it gets suddenly really expensive. And if you don't have a good health insurance in that country, which is the US, you may run short of this molecule, of this medicine, and you will face, of course, health issues. I talk with Europe. So in Europe, it's mandatory to have a health insurance, and insulin is provided by the health insurance and the health system. So we don't really have this stringent issue of having an open source way to produce insulin to supply people. But it's worth to mention that these do-it-yourself biology projects are going in direction medicine. And now I will explain you the next project, which is this 4 Thieves Vinegar Collective. And they are producing an apothecary lab, which is an open source set of tools, which is hardware, software, a lot of glassware. So the tools that usually you find in a lab, and to reproduce protocols and processes that non-expert can reproduce to produce patented molecules. For example, they are aiming at so first their first issue is the EpiPen, which is an injector, a syringe for adrenaline, so which is used usually in to cure in crisis where the body goes in shock and the heart stops beating, and you need suddenly an injection of adrenaline to make the heart beat again. And these EpiPens are cheap, so are expensive if you are in a low income family. And so you want to open source them to allow everyone to have their own EpiPen, and to also put pressure on the system selling EpiPens. But this group is also researching and trying to open protocols to reproduce the drugs that cure HIV, for example. So it's a very ambitious project. And by sharing this knowledge, it's possible to create an environment that better suits a more collaborative medicine research, and to give access everyone to drugs and to medicines. Of course, there is a note here that I want to mention. If you produce yourself something that you have to inject in yourself, well, you have to be really in a bad position. So I never recommend to do that. But this project wants to foster and at least to push on the research on these topics to really allow everyone to participate in this research and to have a wider base and to arrive to solution quicker. So we have talked about patented wetware, and in the same way as hardware and software have their own licenses, the wetware and the biology world is undergoing the same process, because we have so there is the issue that when you exchange material between laboratories, you don't know, so you know that you can use it for research purposes, but you don't know if you can, if you're allowed to redistribute it, to sell it, to reuse it, to modify it. And there is so if you're interested in this topic, you should definitely look into the open material transfer agreement, which is the first study and the first attempt to really reproduce a license, which is very similar to hardware and software, and allow also wetware and biology to be treated the same and to as the hardware and software, and to create the same working environment that is present nowadays for hardware and software. So what's going on in biology, and why is it so important to have such a collaborative environment? So biology is undergoing the digitization process, which is a process that is converting all the information about life in a computer readable format. What we are seeing here is a sequencer, we call it in biology. It's simply a DNA reading machine. As you see, it's an USB machine. It's really small, and it's possible to attach it to your computer, to your laptop. And the cool thing, the very cool thing, is that you don't need a supercomputer anymore to run such experiments. But it's extremely easy. I did it on my own in a study in a consultancy for the telecommunication company of Germany, where we tried how accessible is this technology to people. So in that frame, we rebuilt a temporary biology lab just to sequence, we call it, to read the life instructions, the DNA of a virus, which was innocuous, which was not dangerous at all for humans, and of a bacteria found in fish, in fish that usually people eat, to see how easy it is for people, for individuals to have access to this knowledge. And of course, it's really easy. We did it. We managed. And on the right side is what we see. So this is how the live code looks like. So it's very much like software. It's really, and when you read this set of letters, you can evince a lot of information about how individual works, how diseases are made, and how does it work, all this system. So you can learn really a lot about how an organism works, how a living being works, and how to repair it, how to damage it, how to repair it, and how to use these living beings for our purposes. For example, use mushroom to produce materials that are recyclable and reusable and recyclable and don't impact our environment, like plastic, don't stay into the environment, and at the same time are easy to produce. Or also, or like the guy at the Science Hack Day was doing, you can engineer these microbes to eat plastic. And yes, this is what the digitization of biology is bringing. Of course, having such a big amount of data requires lab automation, which means that you need robots that do the job for you. And there is a lot in the open source environment as well. On the left, we see the OpenTrons, which is a pipetting robot. Pipetting is the action that the biology does in the laboratory, which is used to transfer a tiny amount of liquid. You can imagine 1 microliter from one tube to the next one. And usually we call them 96 wells, which is which are simply plates with 96 tubes, and you have to, so in the old times, you had to one by one pipette the samples from each well, and now there is a machine that does it for you, and which means that you can have thousands of samples and process them really hundreds by hundreds at a time. And on the right, we see another way to move droplets, to move liquids. This is an open drop, and the droplets move on these chessboards. The advantage of it is that it's really easy to see, and it's a great learning platform, but also at the same time makes biology programmable, which means you can load a software, push play, and the machine will execute the experiment for you and upload you in internet the data, the results. So it's a great advancement so here's the basic in the open source of the automation in biology, but also it shows us the way the future will be. And of course, on the left, and now we see how to scale up these technologies. On the left side, we see the proprietary technology, the device which is able to read the DNA. This tool is simply 48 of these small devices that were attached by USB to your laptop, to your computer. And simply these 3 cages are supercomputers that handle the data that is produced by these 48 cells. And this is a great device which will, it's allowing ourselves to study our environment practically, because you can see exactly which microbes are living around you, and it helps you to tackle issues like antibacterial resistance in microbes, in bacteria, which is an issue because bacteria are becoming strong to antibiotics. And yes, we cannot kill them anymore, and not as easy as we did in the past, because they are exchanging information about how to survive these antibiotics. And with this device, we can at least check exactly which diseases or which pests are in the environment. It can be used also into agriculture, because it tells you which pests are in the fields, or to sequence human DNAs, and to check how we are done and how each individual works, and to fix eventual imperfection that individual has. Nowadays, this is possible. And on the right, we can see how to scale up the system of the open drop, which is open source, and see and check how to produce an environment, a research environment, which everyone can use, because now these devices cost around 500 euros. It's still expensive, but it's affordable. It's in the affordable range. And in the future, there will be more of these and cheaper, and therefore more people will be able to have parallelized experiments running at home or in their basement, and therefore to have the same strength of a research group. So what are the benefits at this point of the lab automation? So you can parallelize a set of experiments, and when you parallelize, you have a reagent reduction cost, because you can better plan your resources and your shopping, and everything is more accessible. Then you don't need a lot of personnel, and which means you don't need a big research group to run an experiment. And this is cool because one person can do the job of 10 persons. Having that miniaturized in these tiny robots also allows you to avoid having big rooms, having 3 or 4 different rooms, but you can have just one, which reduces also the costs of the space needed and enables more people to have such a space where running these tiny robots and tiny experiments. And this is a great thing because you lower actually the knowledge needed to execute an experiment, because you don't need a lot of requirements fell, and you can and having the whole process being programmable makes it simply plug and play, also biology plug and play, and this is what we want to achieve with lab automation and open source lab automation. With this, you can enable also small entities to start research projects, because at this point people come together, create a community, a local community or a local hub. And when you have this local hub, you can share protocols or the way you do research in your laboratory, and other people can learn from you. And this creates a collaborative open research environment. And this is my vision, to create and support exactly these worldwide environments. And then, of course, having the same and sharing according to the same principle that I was telling you at the beginning, that you know even more than me, I think, about using the protocols and modifying, learning from them, and redistributing the same thing that someone else that are researched in this open source environment. And once everyone has access and can sell and redistribute those biological protocols, at this point you really can speed up the prototyping and the testing of new ideas, and you will really boost the innovation process. And at this point, then the community is able to challenge also big companies. So about this do-it-yourself biology movement and innovation in biotech, if you want to know more, you can start to read this this paper, which is the inclusive innovation in biohacker spaces, the role of systems and network. And this gives you a nice overview of what's going on and the opportunities. So because people here are afraid of these biohackers producing bioweapons, but actually in my years of experience and meeting people, I never knew anybody, so really nobody, that was working on that topic. The question always came up, so if someone does something dangerous, but nobody did. And in this position, at this point, the benefits are outweigh the negative part of the negative aspects of these environments. So we need to, so the things that we can do is to simply foster and keep sharing. And if we keep sharing, everyone can benefit from the movement and nobody will have interest in doing bad things. So about the people, this study was focused on checking which kind of people work in these innovation environments. And well, you see that often there are these people that are trained individuals that have extensive experience in academic research. And they want finally to bring their own initiative, their own projects to life, which sometimes is not possible to do in academia because of political reasons, because maybe the research topic is uncomfortable for the local environment, because it could damage some companies that are working with bad practices. And so these individuals usually bring together the classical partners like academia, companies, and government. And everyone is involved into running these kind of spaces that where community come together to make biological research. And this openness, the cool thing of these spaces is that their open nature allows artists and designers and all the non-experts to join and to try their own ideas. And they bring these transdisciplinary impulses that really bring additional value to the movement. And bringing these additional values and impulses is what drives then the user-driven innovation, which is much more solution-oriented and much more user-centric. And this is why open sourcing biology is so much powerful. And which kind of activities do these people that meet together do? So basically everything starts with playing around with biology. What can we do? It looks kind of a hobby, because people try simple projects and just to get in touch with their curiosity, with the tools that are needed to then forward, and also to generate their own idea, to generate their own research question, because this is then what makes science what it is. Because you have a question about a problem or about a phenomenon that you witnessed, and then you have to structure the question in such a way that you can get an answer, and you start playing around these concepts and this matter. And while you do that, you undergo an educational process where you learn actually how does it work. And this is where open source hardware and software and maybe wetware will come in place, because this allows you to speed up the generation of knowledge in the section that you are actually studying, in your fields of study, in your initiative fields of study. And what happens next is that simply while undergoing this learning process, you go towards outside and you find new people and generate a very tiny network of people that research on same topics. And when keeping doing that, it becomes actual research, because you end up learning the same methods that are used in the academia, or if you already know them, you simply apply them. And you generate answers that are also new, because maybe at some point, nobody gave answers to the questions to the original question that you had. And so you give new answer. And at this point, That's research. And what about these outputs? So basically, in this movement, then you translate them in entrepreneurial projects. A lot of these curiosity and solution-oriented projects are translated into companies in sellables. And this is what makes that movement cool, because in the very end, you can enter the market in an open source way. And now the challenge, of course, of nowadays is how to create an environment in biology which both facilitates entrepreneurship and keeps open source, keeps the documentation open source, and other to facilitate to follow the same path that was opened by the lead of this initiative, and collaborate and push these projects further. So at this point, you can ask yourself, how does this come together? How do these people regulate themselves? And yes, I see someone. And the cool thing is that so there are two main issues, because usually when you research on biology, you have relaxed, so you have a lot of biosafety rules, and in these spaces, individuals usually just start doing things before achieving the biosafety rules. And in these spaces, the cool thing is that because there is just one process, just one project, it's possible to tailor the biosafety rules to exactly to that project and to make it safe. And of course, if the government comes to help, or there is some funding to ensure and to enable those researchers, those do-it-yourself biologists to comply to the rules, it's even better. And this is what then makes the space grow and a community grow, and to have and to achieve safety. And the other issue is to have a flexible IP intellectual property systems, because in the same way that we saw for hardware and software, if there is intellectual property, it's really hard to have a community and to have sharing. And these communities, these do-it-yourself biology communities, are the licensing, are sharing whatever they are doing. And this is to create the same environment for hardware and software. And yeah, so what's the output of such an environment? Because someone can argue and say, yes, but in biology, in medicine, and in pharmacy, you need to patent something to do a product. But then if you check better, it's so these people that are proposing solution, they are proposing solution that they want to use. Is not the same thing as big companies are doing while licensing. And this is a different type of innovation, which is completely new, and it's worth to be studied, and is driven by users, and it's really user-centric, and it's meant to be used. So it will from this field of studies, from these people that initiate these communities, you can expect that the research topics will be aimed to allow everybody to benefit from that. So you will see a lot of environmental projects to support the more sustainability and to have a better life together, or a lot of projects that study food, make food more available, more sustainable, or educate people about food. Or like we said, we saw these very ambitious projects of having an open source pharmacology science, which I think is really cool. And yes, as last word, in my vision, I see that if we manage to create such an open source collaborative biology-based research environment, everyone can benefit. And of course, you as an expert in open source hardware and software can help on different sides of this process, both on supporting the people who are developing biology and providing them the knowledge and history about how hardware and software dealt with the issues of the licensing and creating such big communities of developers. And on the other side, you can develop yourself tools that are both for biologists, for non-experts to learn from, because I had a really hard time to learn about hardware and software, and while I wanted to bring my knowledge in biology and wetware. And yes, I hope in a really productive collaboration with your communities. And well, thanks. And if anyone has questions, now is the time. We can have a tiny discussion about what are your ideas, and if you have inputs or something that you want to say. So please.
Thank you, sir. Does anyone have any questions? If you're not able to ask, please put it in chatting. If anyone have any queries.
Alessandro, I just have a question.
Yes.
Yeah. What are the different open source tools for scientific biological computations that are available?
That's a cool topic. Actually, in bioinformatics, because you need very peculiar algorithms that analyze your data, everything is basically open sourced. What happens usually in biology is that you install special version of Linux. I remember using Fedora or environments where you can really tweak the very basics, and used a lot of Python. And there is no open source package as package, because it's everything online. You can check the NCBI, which is the National Center for Biotechnology and Information. And in this database, you find there is all the data, a lot of data released that allow you to do a lot of research, and all the basic tools to search into DNA, into the DNA blueprints. So, for example, you can imagine it as a Google of life information. If you want to know how your bones are done, which is the code that runs the bones, you can go into this NCBI. You can go into this Google. It's called BLAST, so basic local alignment tool searching tools. And this is a Google of information, of live code. You insert your live code, and it looks into diverse animals and looks for the code. So yes, I would recommend you to go towards NCBI and to start there to learn. And if you know Python, Python is the most used language by informaticians, because it's really user-friendly and easy to understand.
Do we have any more questions from the audience? I think they will also be interested in knowing how you ended up in open source. Being a biologist, what was the real inspiration to go the open source way?
Yes. Yes, but my story was so quickly said because the time is running. I always, so since when I'm very young, since I was I think 15 or 13, I really enjoyed going into walking in the forest and really enjoyed the environment. And I really took on myself the issue of people leaving trash around and polluting the environment. And so I decided to study biology to make to implement my own solutions and to help with this issue and about reducing the human footprint on the environment. And so I studied biology, I graduated, I worked in a laboratory. And then when it was the time of going for a PhD, it didn't really work because what I wanted to do wasn't exactly fitting the framework of the PhD. So I fell off of the academia, and then still I wanted to push on sustainability. And so I'm born in Italy, and so I moved to Germany. Now I'm based in Berlin, where it's a big hub. And yes, to do that, I needed simply to build my own laboratory, and here we go. So I started reproducing the open source hardware that luckily was made available, and so I'm really thankful to people that have developed such tools. And now so with other people, we founded a space which is Top Lab in Berlin, which is meant to be a community lab. And we are involving more and more persons to build upon it and to join us. And we have different topics running now, so which is the collaboration with the university about fungal materials. There is my own research about automation in the lab, and the collaboration with Gaudi Labs, and the guy which is producing the open drop, this open source robot to move droplets, the tiny one. We are doing now we are opening the algae tracks, how to produce bioplastic, and the bioremediation with mushroom, which is also how to degrade plastic using mushrooms, or to train mushrooms to decompose plastic. And we have a community of people sharing protocols about how to produce edible gourmet mushrooms to be eaten, and to have sources of food, and to use basements of the city to produce food. And I think this is very inspiring, and that's the direction I want to go. And this is what inspires me. So simply, I really want to enjoy the environment and to live, to have a nice environment where everyone can live into. And this is what inspires my actions and push me forward. Very simple.
Thank you, Alessandro. So thank you so much for being with us to share your thoughts on open source DIY biology. So looking forward to associating with you on future events also. Thank you so much.
Yeah, thank you for the time and for the opportunity to to give this insight. And yeah,
sure.
Let's see what's coming. Now I will follow the session and see.
So we'll be having a panel discussion now, open source in industry. So transferring over to the moderator to take the initiative. Thank you.
Bye-bye, everyone.
Bye, Alessandro.
Bye, Alessandro. Thank you.
Amal, Karan, Sayan, and Vimal, shall we start? If possible, please on your video.
Hi. Hey, Sanya. Hey, Karan. Hi, Sonia. Hi, Vimal. Hi. Hi, everyone.
Hey, everyone.
Hi, shall we start?
Sure. Do you want to do a quick audio video check?
Yeah, we can hear you all perfectly.
Brilliant.
Yeah, Sayan, you are here? Sayan?
Yes, I could see Sayan here on the video.
Okay, Sayan, can you hear us? Sayan?
I guess Sayan is having some mic issues, is what he's put in the chat.
Oh, yeah, I see that now.
Yeah, Sayan, 1 second. We'll rectify it from our side. 1 second. Sayan, can you turn on your mic now? I hope it's all.
Yeah, can you hear me now?
Yeah, we can.
Cool.
Yeah, we can see you. Yeah.
Yeah.
So I think we are good to start.
Yeah.
Yeah, over to you, Sania.
Thank you, Dekasa. Good afternoon, everyone. Now we are here to have a panel discussion on the topic open source in industry. I'd like to welcome you all here today. Myself, Sani Thomas, Assistant Professor, Saintgits College of Engineering, got to be the moderator of this panel discussion. Before we get started, I'd like to take a couple of seconds to acknowledge that we are still in the middle of the pandemic. All the stress and strains that the pandemic has brought in a multitude of ways for the past 15 months has been really tough on everyone. However, we have to face it with all positive thoughts. And this won't stop us as we are still connected virtually. This shows that we are resilient because together we are stronger. Now coming back. Here we have with us eminent panelists, Mr. Amal Mathai, Mr. Karan MV, Mr. Sayan Chowdhury, and Mr. Vimal to share their thoughts and points on this topic. This panel discussion is about 16 minutes, and the last 10 minutes is for Q&A. At that time, the audience can have an interaction with the panelists. Meanwhile, the audience can also jot down their queries in the chat box as well, so that the speakers can either weave them through their discussion or can address it at the end of the session. Without much ado, let's quickly go out to the discussion. I feel it would be better if the panelists could introduce themselves to the audience. You can take alphabetical turns. So let's start with Amal.
Brilliant. Thanks, Anya, for setting the context and having the session rolled on. My name is Amal, alphabetically A, but then people call me Mathai, so I should have actually come with an M. But I think it hardly matters because being a K, oh yeah, K, you should have gone first. So myself, Mathai, I work as a technical delivery manager for training and certifications with Red Hat. Been associated with open source quite some time now, 18, 19 years. Been with Red Hat for around 15, 16 years now. That's all about me. I would just be trying to make some contributions to the expert panel discussion here. Back to you.
And Karan.
Yeah, hi everyone. I'm Karan, and I lead developer relations for GitHub in India. I'm very closely associated with the open source ecosystem, and in fact, my work a lot in GitHub is to help grow this whole open source ecosystem in India, and work very closely with a lot of the contributors, developers, maintainers, businesses. A lot of the investors as well, and then also various organizations and across the various different stakeholders who are part of this growing open source ecosystem here in India. Back to you, Sonia.
Sayan.
Yeah. Hi, Saya, and hi, everyone. So, hi, I'm Sayan. I work for Microsoft, and I've been part with open source for around 10 years now. I started contributing while in college, and I've been associated with a lot of open source programs. Like I've been primarily contributing to OS called Fedora, and then recently I I joined this company called Kinfo, which was like a completely 100% like with at open source at core, you can say, and we built a Linux distribution called Flatcar Container Linux, and I was one of the member of the team. And I've been very actively working on to build a community for the projects, as well as trying to build the distribution as well. Other than that, I've been also part with different Indian Python user group, also been the chair of PyCon India last year, and been helping with the team for this year as well. So I am really delighted to be part of this panel discussion, and I hope to share some thoughts on thoughts on this basically. Thank you. Thanks. Over to you, Sania.
Vimal, I think you could
Yeah.
share.
Hey, Sania. Thank you. Thanks, everyone. Thanks, everyone, for inviting me to this this discussion group. So I'm Vimal. I work as a digital consultant here at Sixware Technologies, and I run a small unit within Sixware, which works closely with the business to help them grow their business through digital channels. And my experience with free software starts at 2001 when I was in college, and then no, it was almost 20 years I am been in this community, and I'm really lucky to be part of some early initiatives, especially the one that initiated free software implementation in schools in Kerala, which is now more called as IT at school. So I'm happy to be part of building a distribution for schools at that time. It was around, I guess, 2004 or 5. And now they are continuing that tradition, and now every government aided schools in Kerala is now using free software. Yeah. So looking forward to have a good discussion with everyone.
I hope that audience got a clear idea of who are the panelists. So I'll move on. That nowadays enterprises are promoting open source adoption, and I would like to know how does open source culture work at your office. Maybe we can take a reverse order now. So Vimal, I'll start from you.
Yeah. So thanks. So I would use a different term than open source. So I call it as free software, just to make sure that we cover the larger picture. So for me, open source is just a development and collaboration model. But the larger philosophy, when we talk about knowledge sharing and contributing back to the society, we should use the term free software. And no, I am happy to be working in a company called Sixware Technologies, where we set our vision as an organization committed to free software. So we are not just talking about open source, we are talking about the larger picture where we encourage collaboration, we encourage contributing back to the society, and yes, we also use free software. So in our case, so we are working on a platform called Drupal, which is one of the largest free software community around the world. So the motto of this community, this specific community, is Drupal community is like come for software and stay for community. So that is the beauty of it. So people come here to use or download Drupal. So Drupal is a CMS, web CMS, which can be used to build websites, and it is extendable so that it can be used to build anything that is possible need to be published on web. So we are an active contributor. So as a company, Sixware is an active contributor to the development of Drupal. We encourage our developers, employees to contribute back to Drupal.org. The first thing that we usually do when an employee joins in, we'll get them a Drupal.org ID, and whatever free time they have, or they have not allocated to a specific project, then their task is to contribute, go through the issue queue and fix bugs, or maybe contributing back to Drupal.org. And also, wherever it's possible, we will make sure that the general purpose piece of code that we create for our customers with their knowledge and permission, we contribute it back to Drupal.org. And some of the modules that we contribute is used by tens and thousands of websites, web projects all over the world, and that in turn help us get new business as well. So being in this community and contributing back to the community is, in return, we are also getting new business and opportunities to work on larger projects. So so when on the academic, on the industry front, we are 100% benefited, not by just using free and open source software, but by contributing back. So with that contributing back to the community, help us establish a position within the community, and at the same time will help the potential customers understand our competency and capability in the system, and our understanding of how the community works, and how what will be the direction of the platform that we are working on, help us serve our customers better, as well as at the same time it improves the platform itself. So really we encourage everyone to contribute back in our organization. So it is we are trying to get that as part of our culture itself. Okay.
Thank you, Vimal. And I think Sayan, you
Right.
can share your thoughts on this.
Sure. Yeah. So as I told, like, I've been working with this Flatcar community, and this was part of the company I used to work with, called Kinfolk. And a month back, Microsoft actually acquired Kinfolk through Microsoft Azure, and the plan is to make it the community bigger. And we had basically a bunch of projects under this whole Kinfolk umbrella, and one of the things that we had was open source, like by default open source. So all the projects that we had was primarily open source, and we termed ourselves as the Linux experts. And the core areas that we worked on was this: the Flatcar was the Linux distribution. We had a Kubernetes distribution which was called Locomotive, and then we had other projects which was mostly around observability and eBPF stuff. So all of the projects were are open source. And after the acquisition, I would say, like, how things changed was, like, we started, one of the focus is right now to build the community. So we started doing our monthly Flatcar meetup community calls, so that more people can join the call, folks, because it's open. So we try to invite people in to give talks, to show how people use Flatcar as their probably home lab, or probably in their company, so that other people can be influenced. And we also share out, like, how Flatcar is built, and show them small demos. And the idea here is that at the end of the day, we are trying to build this community where we try to make the path of the open source contributor easy enough so that they can start contributing, be associated with it, and grow the Flatcar distribution to the next level. And this can totally, and I would say, like, can happen because of the community. And from the other perspective, I would say, because we are open source by default, so any discussions that happen, anything that we try to do happens on IRC, and that is something which is when we join the team, and it is usually enforced, or rather I would say like kind of passed on as a knowledge that please try to talk in public so that more people can chip in. It becomes a point where it becomes very easier for contributors to get in, and that's how we are trying to build the whole Flatcar community, as well as the similar approaches has been taken for the other projects which are out there, like the Inspector Gadget or Locomotive that I was talking about. And given Flatcar is a distro, so it's not only limited because it is made up of, I would say, a bunch of other open source projects, and this gives us this opportunity to try contribute to other open source projects if we see if there is issue. Like suppose the one thing that comes from the top of my head is that there was this Golang issue which was breaking our stuff, so we directly went ahead and fix that. So it becomes a kind of a it becomes a part of your nature that you try to have everything pushed to upstream rather than having everything in your own cocoon. Rather you push those things and then ingest those from the upstream rather than having patches in. And that is actually one good thing. Like I have been associated with open source for a long time now. I've worked with previously I worked with Red Hat, which was where I worked for 4 years, and I primarily have worked on the whole the primary work there was also like working on open source stuff. And I feel this is how you end up building, and when it makes me very happy when you see contributors chipping in and contributors having more contributors coming in and sharing the work with them, sharing the knowledge with them, and so growing the whole community with them. It's just not a single like it's basically total community's job at the end of the day, which builds the whole project at the end of the day. So yeah.
Thank you, Sayan. Karan?
Yeah, it would be a really interesting question, for GitHub, because anyone who might have used or heard the term open source, would know that GitHub almost today is in, like the center of open source, where a lot of the development happens on GitHub, a lot of the collaboration happens on GitHub and things like that. That's something that many of you might already know, but the interesting thing that I want to add in and share over here is also how a lot of the other enterprises are, starting to use open source. So it's not just individuals and people who are interested in a project coming together and working on it, but there are a whole lot of other enterprises in India or even globally. They are having dedicated open source program offices within their companies to kind of focus on open source itself within the company. So when I say focus on open source, some of the organizations specifically want to ensure usage of open source instead of proprietary systems, or they want to ensure and encourage their developers to contribute to open source, or they want to maintain relations with their peers and other folks whose products they're using to understand how open source is affecting their business and things like that. So it's not just anymore about few people, developers over here, few people over there, but even all of these larger enterprises and companies who are looking very specifically on open source, on okay, what we can do, can we use, can we contribute, can we even support monetarily open source developers and projects. So all of this is something which is happening right now, right today, and that's one of the main reasons why many developers are not just using but also have started contributing. The second aspect that I want to share is that there is also a concept called as inner source. And inner source is basically wherein it's like open source but within an enterprise. So generally when we talk about open source, we talk about it being available publicly for the whole world. Whereas inner source is again a concept and something that's being used by many organizations, wherein they might have multiple teams who are working on various different projects and various different code bases and things like that, but have a lot in common. Yeah. And they often figure out that they're repeating stuff. So what they're doing is they're essentially setting up an open source practice, but within the confines of the organization itself. So it's essentially what is called as inner sourcing. And the third thing that I want to share on this is also how we as GitHub are contributing back to open source as well. So if you go to github.com/GitHub, you will find a whole lot of open source projects by GitHub. In fact, various parts of GitHub that you might be using already, things like language detection within many of the repositories. It's a project called Linguist, which we have open source. Or there is one of the sections called as Explore, github.com/explore, where you can find collections of projects or topics and things like that. This is again being curated in the open, where there is a repository where you can go and contribute or look at other contributions and things like that. And we contribute upstream to a lot of the projects that we use as well, be it Ruby, or be it a whole lot of other packages and everything else as well. So it's very interesting because we as GitHub not just like enable open source, but also contribute back and then support as well. And I think it's open source is going almost to a way where it's not just about software, but also about a lot of the human missions. So if you look at it recently, as a part of the recent Mars mission by NASA, there was the Ingenuity helicopter that was prototyped and a proof of concept that was launched, and open source was used there as well. So in fact, if any of the contributors have contributed to specific versions of those open source projects that have received like a badge as well. So it's amazing to think that if you are a developer or a contributor to open source and you contributed something, knowing that your contribution is a part of one of those projects which is actually helping humans fly a helicopter on Mars. That's really amazing. So that's what I wanted to share on this.
Thank you, Karan. And Matai, I think you could share your thoughts.
Yeah. So you know what, the benefit of talking at the last in an order is that most of your points would have already been covered. By the way, Sayan, glad to meet an ex-employee of Red Hat. I never knew that you work for Red Hat. So well, we strike a relationship there. So when I was actually listening to these folks talking, right? What I find is that on this panel, which is talking about the significance, the future of open source, Sania, I think you have brought all like-minded people. Everybody has been going about, wow, open source is great. This is my life. I love open source. Actually, we should have had one more person who is not very pro, open source. So when I actually listened to Sayan, he was talking about, being on IRC. That's the kind of legacy they pass from, from developer to developer. They are encouraged to, talk in public. Vimal was talking about the community. So I just captured a few words, right? So Vimal says that community, I contribute, I get back. Sayan was talking about, public, make everything public. Share your ideas in public. Now, the thing is that there is nothing secretive going on there. It's more of talking about it in public and then take a feedback and make it better, right? And Karan was talking about collaboration. Karan was even talking about enterprises, so many enterprises. And I know for sure, I'm not taking names here, but then still I know for sure so many enterprises which are not very open source in nature. They are very proprietary in nature, but then still they have a lot of open source activities going on internally. And I like, definitely like the idea of inner source, which Karan was talking about. And so I think most of the aspects have been spoken about. So for me, agreeing to and accepting and understanding that I have gone through all these phases, which has been put forward by my eminent co-panelists, I would also like to think that open source to me, well, it has fascinated me, and that is the reason why I've been with this open organization for 16, 17 years. I joined Red Hat in 2002. And well, I started on the rolls of Red Hat in 2005. Until then, I was on a contract role. It's not just about me getting fascinated. Later, when the reason why I stated the year and the reason why I mentioned I've been so long in this organization is because of a couple of facts. One, it has fascinated me, and I've been part of this journey. But the other reason I mentioned that is because since I've been part of this journey, I've seen the transition of how open source has become. Maybe in the early 2000s, and then if you look at Karan talking about so many projects going on GitHub.com, and then it's a collaborative space, etc. So to me, well, of course, the community, free speech, free software, sharing code, collaboration, everything goes along with that. To me, it is also a culture. So the question, since it was specifically about how does it happen in your organization? Well, I am proud, just like anybody else on my panel, proud to say that I am associated with an open source software company. But at the same time, it's also about how do you get that culture? How do you get those aspects brought into life when you're actually part of your organization? So I'm sure many of my fellow Red Hatters who would have joined after me or recently, they would not have had this idea. But then we do have programs in our organization where we help the new people understand why are you doing this, the why of this organization, the purpose, the culture. So for me, it is about, in addition to all that has been spoken, it's also about culture. Now, when I talk about the open culture, there are a few contributions which we make also back to the community, back to the industry in terms of organizations to go open. Open Organization, a book written by Jim Whitehurst, who is our ex-CEO, is one of the examples which I can cite, one of the many examples which I can cite. So to me, in addition to what others have spoken, it is also about collaboration, transparency. It's about inclusivity. It's about not any project in Red Hat, I would say, has always had been decided the features or the fixes to that product has to go at that level, right? It has always come from across the organization. So it's about, well, it's mostly about the collaboration, the inclusivity, the transparency, right? So for me, open source has been my life, and it's not just about the software. It's also about the way we live. So for me, it is in my blood.
Thank you, Amal. So for a new, who are coming to this space, especially they'll be coming on the assumption that everything is available for free. But there is a saying that there is no free lunch. Why software compliance or license compliance is important, and what are the suggestions you would like to give to a newbie in open source? Maybe Karan, we can start from you.
Yeah, that's a really good question. Because in fact, when it comes to open source, right, there is always different key differentiators. So there are of course multiple terminologies and terms out there that folks are comfortable using. Be it open source software, or be it free and open source software, or be it free software, etc., and multiple things, right? But one of the key differentiators when it comes to open source projects is license, right? Because if you look at anything out here right now, just take out software, anything that you get right now. It could be, it could be a phone that you purchase, it could be a laptop that you purchase, or it could be anything pretty much, right? You always get it with some sort of, legality, with some sort of license, maybe, where I'm using as a loose word, but some sort of, understanding and an agreement that this is what you can do with it, this is what you cannot do with it, and this is what we can be helping you with, and this is what we have nothing to do with, and things like that, right? And an example is something like if you just buy a phone or a laptop or something like that, right? Essentially the manufacturer is kind of giving you a license to use it, but maybe not to modify it, maybe not to just take it apart and then do whatever you want with it and things like that, right? So so similar concept is what applies to softwares as well. So most of the softwares that you get right now have some sort of a license. I'm not just talking of open source, but pretty much any software, because they're all consist of some amount of intellectual property, because folks have contributed to it and everything else, etc. Even if it's like internal developers. So license is that one specific thing that's very, very special to open source, because when you put a software out there in the public, and then out there in the open, there are a whole lot of things that can happen. People can, of course, use that software. People can modify that software. People can add their own things into the software. People can add their own things and redistribute it as something else. People can build off something out of it, etc. Right? And of course, there are multiple use cases. It can be used just for me. I can use it for my company. I can make a business out of it. I can make money out of it. I can run a garment out of it, and things like that, right? So to kind of say what's fine, what's not fine to do with this specific software is where license comes in. So, and of course there are various schools of thought when it comes to licenses, in terms of what access or what kind of flexibility that the license provides, and whether that's suitable for these kind of projects or not, etc. So often the approach is that right now when you go on github.com and you're creating a new repository project, you are asked as to what license do you want to apply for this project. And there are multiple websites, including like chooselicense.com or multiple other ways where you can understand, okay, what are these different licenses, and you don't really have to be like a lawyer. Of course there'll be some legality involved, but there are always some certain key things that differentiate one license from another license. Things like yes, you can use this software in your software, but this license file should stay as it is. Or it could be like, you can use this software in your software as well, but it should also be under the same license as my original software, and things like that, right? So it basically kind of helps people who are creating and contributing to open source give a direction in terms of what this software is really meant to be, or how it's intended to be used. And for someone who's consuming it, or even someone who wants to contribute to it, understand as to what they can and cannot do with those softwares, right? So I think that's where software licensing becomes important. And many of the developers, contributors, maintainers kind of step away from it, not thinking much about it. But it is very, very, very important given the current scenario, because think about it, you might be writing some really, really good software, but say for example, what if it lands in the hands of wrong people, or if it's put to your wrong use. So it becomes more important to kind of develop, contribute, and maintain responsibly as well, in a way such that the direction of the project is what it is intended to be.
Thank you, Karan. So I think Vimal, you could contribute more on this topic.
Yeah, so Karan stressed the point that it is really important. So mostly developers do not care which software license they use, and and even the users are kind of not trying to understand for what kind of purposes the software that I am using can be used, right? So it is really, especially when you work on free software, when you collaborate on a project that is already on free software, it's extremely important to understand the type of license it uses, and not a very hard thing. You do not need to be a lawyer, as Karan mentioned, to understand what this licenses means, and there are many resources available on internet which explain these licenses in plain language. But when there are there are lots or tons of different licenses available, and it is always a confusion to choose which type of license for my project, or to understand what exactly this particular license is allowing me, right? So there are if I would say, if I categorize these licenses, there would be kind of two major kind of licenses. One is the permissive kind of licenses, which allow which do not care what you do with the modifications. So it only cares about what the code that is already been written in that particular license should stay in that particular license. But whatever modifications you make on top of that modification, you can keep it under any license that you want. That is one kind of license, which is called permissive license, and the other kind of licenses are called kind of really not very permissive, but it is called reciprocal licenses, where it says that whatever changes that you make, that also should follow the same licenses as the original code. So Drupal, for example, uses GNU General Public License GPL version 2, which is a reciprocal license, where if you make any changes to Drupal, you are obliged to make those changes also under that particular license. So you cannot make that changes as a proprietary code or any other license. But if you say, for example, if you go with a BST style license, there are certain clause that allows you to make your customization on top of what it is already there, can be proprietary. So if you extend something and you are not touching the existing code, but you are extending it, but that extension can be under any license that you want. And there are other types as well, so I am not getting into the details, but only thing I want to stress here is that one, if you are trying to contribute to any free and open source software, you should first check which license that is in, and whatever code that you contribute, you should think about whether you need to use that particular license, or what is your purpose. So based on your purpose, you need to decide how do you want to contribute to that community, right? And also, if you are using a library or a particular package which is already under a particular license in your project, you need to make sure that that license allow you to or maybe compatible with the license that you are planning to use with your software. So it is so that is all I want to tell you. So if you are not mentioning any license with your software, that means it is copyrighted, and it is no one else can use it. By default, any software you write, by default it will comes under copyright law, and no modification is possible unless explicitly mentioned by the author. So that is why it is really important to specify the license with the software that you write. And it is important to choose the right license that you are aligned with, or no, you want to use with the software that you are writing. And it also applies when you borrow code from some project. Say if you do not use the entire library, if you are just using few functions from an existing free and open source software, it really matters that which license that particular software is in. So anyone who wants to become a contributor to code on any free software projects, you should put some effort and time to learn how understand the minimum basic stuff of what all these kind of different licenses means. At least you should be familiar with some popular licenses like Apache, BSD, MIT, GNU, GPL version 2 and 3. So yeah, so those are the kind of popular licenses, and you should try to get familiar with these. Yeah, so that is what I have to say on this.
Thank you, Vimal. Again, Matai, we are again coming towards the end. I'm just coming to Matai because we'll get more insight on this, because you will share all the, taking all the contributions from other panelists here. You are concluding it, right? So now I'm just coming to Matai. Just can you give your thoughts on this, about this software compliances and how it is important, and what you will suggest to a newbie who are just coming to this open source?
Right. So, no, my view is, think about why did this open source happen, right? So software was built by developers, mostly for developers, and it never used to be a user-friendly or a smart-looking, good-looking kind of software. And at that point in time, when developers felt that, hey, somebody has built a software with bugs, all right, and selling it, or somebody is forcing people to pay a rent or a loyalty or a fee for using that software, versus all the licenses which or all the types of licenses which Vimal has been talking about, which Karan has been talking about. If you compare and contrast this, whatever licenses we have been talking about as part of the panel is always on this side, where it is benefiting the users, the community, and the developers, versus the other side of proprietary software. Now, if you think of that big picture, no matter whatever license which the panelist has been talking about, even if they exist, it is absolutely fine, because at the core of it, we are all on this side, where the other side was a world of proprietary software. And it made a huge difference. Now, GPL, GPL1, GPL2, GPL2, 3. I mean, I also come from an organization where the subscription, which we call Red Hat Use It subscription, when people need support for the Red Hat enterprise solutions, which we offer to our customers, you just can't replicate that, buy for one subscription and use it for multiple machines in your data center. So, and as Karan was rightly mentioning, if there is a project which is very sensitive in nature and which should not get into wrong hands, there are certain measures which has to be in place. And Vimal was directing the audience in the right way, that you have to choose what is that your software is going to be like. Is it going to be completely GPL'd? When Vimal used the word copyright, I suddenly was taken back 16, 17 years, where I had a T-shirt which had copyleft. I don't know if people in the audience would know what copyleft is, but those were the days when we used to evangelize open source software like anything, and we used to have T-shirts like in the world, in a free world, there is when there are no fences, we don't need gates. I'm sorry, sign. And and also the copyleft thing. So what it all boils down to is that no matter how restricted your software in the open source world is with certain licenses, you are still far better off than a proprietary world. Now, what is the benefit we are getting out of it? The benefit is all about innovation, right? Now, there was something which was very specifically spoken by Sign about make everything, discuss in public. I would say it's the same thing in a different dimension happening in our world, in the open source world. We are talking a lot of things publicly. Now, what is the benefit we get? If a developer wants to, let's say it's confined by a bit of clauses in a license, but if you look at the way or the pace at which, the speed at which that software grows, it's all because of that freedom. It's all because of that openness and the innovation which that openness brings in. So to me, I know that technically when you are writing an open software, you have to choose a license and you have to decide at what level of openness it has to go to. But ultimately, these are all helping in one way or other for a better good than the proprietary world. And also, being open will help innovation. Now, I can give you one simple example before I pass it back to you. Red Hat is a software company, right? And when you look at a software company which has got $3 billion US revenue, which is employing only 15,000 people across these many countries and around 150 offices. And if he could actually do a business which is worth $3 billion of annual revenue, it means that 15,000 is less a number. 15,000 includes right from the receptionist to the sales folks, to the marketing folks, to the IT folks, to the developers, to everyone sitting in our offices. And if it is not for open source, I don't think I or Red Hat would have existed. So think of the kind of innovation. So Red Hat is just a catalyst there. Now, no matter what the license is, again, the point I'm trying to make here is open is far, far better than proprietary. Back to you.
Thank you. And Sayan, again, we are running out of time, but still you can brief out what is your opinion about this, like software compliance, like license compliances.
Sure, I'll actually go short. Like my co-panelists actually shared most of the thoughts we learned through the open source journey on how licenses are important, how licenses work with each other. Few of the thoughts, but I'll try to emphasize on as a person who started 10 years back. I kind of saw the phase like when Mate was talking about open source. Back in 15 years ago. So I was kind of in the transition phase, like open source was kind of coming up, but it has picked up in the community. So there was conferences like Foss.in and those conferences happening. And I kind of met people through in those period, met through people, and I kind of got to know about this license word. And someone coming from a college where we did not have a very huge this open source culture. So these all stuff were a bit totally out of the world for me. It was for a newbie, I would say it is very difficult in the beginning, but right now, like there are various platforms. Like if you earlier GitHub did not have this, but right, and most of the people I know back in those days would probably start off with a project, and for them, like creating a project on GitHub would probably mean open source. But then later down the line, you would understand how licenses are important. And GitHub added this very beautiful features of adding licenses while you create the project itself. But one of the major thing I would say, even Mate covered that, is like knowing the culture. So there's actually a very good book by Stephen Levy called Hackers. So if you read through those books, you'll understand how the free software movement started, and that gives an idea. These books actually start inculcating why licenses are important and how this goes into the whole culture perspective of it. Because open source is not just about code; it's about an ideology that you follow at the end of the day. so I do a summer training each year. It's a free summer training that we do, and one of the things that we start off with is the code is the later part. The first thing you learn how to communicate and how to learn and learn about this whole ideology. What was the idea behind this whole thing? And slowly down the line, you can start easy with as a someone who is starting with this. I would say start easy. There are various resources out there. There are conferences. Matin again mentioned about copyleft. So there is a conference that happens called Copyleft Conf in Brussels. I attended those. It was a wonderful thing. And through this whole journey, I kind of become fascinated around licenses, reading more about licenses, though I'm not a lawyer, but then I started reading books around those to understand more intricacies of it. And the other thing that Vimal mentioned was one of the thing was the compatibility matrix law. So I want to emphasize, like if you join a company, or a lot of people like start a startup, so and a lot of companies are based on, like, you use technologies like Django, you use Node, you use other technologies. Everything is like protected by licenses. And one of the beginner mistake I feel a lot of people do is not seeing the compatibility matrix. And when picking up softwares to build the whole stack, matrix is also very important thing to kept into mind to see how licenses interact with each other. So this can become might come at a later step, but I would say this is something a person should keep into mind or spend some time digging into it. And if you're working in a company which like a lot of company, as it was mentioned earlier, that a lot of company has this open source teams inside to help different employees within the company to grow. And if they're pushing out their code open source, these small teams actually help the employees decide on which license to pick up. So if you have this kind of team, do interact with them. And it is because you might not have a complete picture, but they can help you pick up the right licenses and help the project grow. So yeah, so these are few of the points that I would like to just add on top, because the co-panelists did a very beautiful explanation of why licenses are important at the end of the day.
Thank you, Sayan. Now we are just really running out of time, so we'll take now the Q&A session. So we got one question in the chat that can I call my program an open source even if I'm not using any license? If any could answer this question, that would be helpful.
By default, so shall I take that?
Oh, sure.
Okay.
I was just about to say, Vimal should be the person who should be taking this question.
Maybe. No, anyone can take, but no, I have point of view on that. Yeah, so by default, if you write anything and you do not mention any word of copyright or license or anything, by law, it is by default copyrighted. So in technically, you cannot call, even if the source code is available, technically you cannot call it as open source or free software. So if you want to call a software a free software, then there are certain things that you need to comply with. So this open source foundation also have a set of rules or a checklist which makes a particular software open source. So how can we call a particular open source? There is a well-defined description on that. So you can search for that and find that. But the quick answer is like if you just publish the source code, it doesn't mean that it is open source or free software.
Yeah, also I just wanted to add one other thing over there is that, there is an open source, guide itself that, GitHub and many of the other folks, all of us have put together, which is called opensource.guide website. And, if you know about the very first thing on the what and why of open source, what does open source really mean? There's a nice explanation, over there as well. I just wanted to add one more other small thing. Since I'm also very much into books. Sayan mentioned Hacker's book, and that was the first book that I noticed in Vimal's book rack behind him. I noticed the Hacker's book, and then I was like, that was the first thing, and then Sayan also mentioned it.
Any other questions? If you have any other questions, you can write from chat, or you can unmute and you can ask. You can even interact with panelists if anybody interested.
Looks like we are saving some time for the day.
Anyway, we have a few minutes. I'd like to ask you, what will be the future of this open source within this 5 to 10 years? What will be the future? So, if anyone could answer about this.
I think I'll take a first short go on it before anybody else chips in. I won't take much time. Well, I don't predict. I do not know what would happen 10 years down the line. Maybe software itself is going to be like irrelevant with all this human pattern design and analysis in the form of artificial intelligence and all that thing is coming in. However, I would say that when a small company like Red Hat can actually cater to 90% of the Fortune 500 companies, when we have 1 million plus open source projects in the world today, when we have around 100 million GitHub repositories which are open source in nature, well, I wouldn't say that all 100 million are different projects. It could be clones, it could be folks. But then, when we have 40 million developers in our ecosystem working in open source, when you have people who are working for companies like Red Hat and then making development and contributing their developments in open source, and most importantly, in 1998, 2000, early 2000, when people had to go and speak about open source for people to get enthusiastic about, and then, as Sain mentioned, it's an ideology, it's a philosophy, and then we had to actually ignite or force it to poke it into people's brain. Today, if people talk about Kubernetes, if people talk about Android, if people talk about CoreOS, if people talk about all these stuff, I think open source is the way to go, is the de facto standard, and is here to stay. I will stop right there, making my comment about what is open source today. Should I go in there or not? That, I think, solves the answer. Over to the rest of the folks.
I'll just add one comment, and after that, maybe, along with the next question, Sayan also can, share some thoughts. Sanya, you asked about, what is the future of open source? I'm just going to say one line. Open source is the future. That's all. Open source is the future. Over to you, Sayan.
Actually, we got one more question. I think Karan is the person who can answer this question. We got one question in chat.
Yes, I saw that. I think that's related to Azure DevOps, which I guess probably Sayan might be in a better position to answer.
I'm actually still trying to understand the question. I'm not really sure what Vijay is actually trying to ask here. So Vijay, if you can come on the unmute yourself, and if you can elaborate the question a bit here.
Hi guys, can you hear me?
Yeah.
Okay. So it's more like so Microsoft has acquired GitHub long ago, and then now it's when the people and the number of enterprises who are actually into cloud is increasing. Plus, Microsoft has introduced Git capability in Azure DevOps. Then it's more automated CI/CD. Everything is actually that move to Azure is actually fastening things up. Okay. So, what do you think the enterprise usage of GitHub will be, or is it more a kill or something kind of?
Oh, you mean GitHub or Git itself?
GitHub. In the sense we can have a project in GitHub or GitLab or Bitbucket or anywhere we want. Okay, but after Microsoft acquired GitHub, right? There are a lot many things that are actually going on, right? they introduced DevOps, and then along with DevOps, just instead of the legacy TFS, they have added Git support also. And then the enterprises were actually moving to Azure. Is actually using Azure DevOps instead of any other platforms. So it's more like they are taking more customers towards Azure DevOps. So what do you think GitHub, the future of GitHub with respect to enterprise usage will be?
Okay, I can take that question. So, Bijoy, when it comes to a lot of those CI/CD and automations and everything else, right? The main thing, the future where it is largely on GitHub Actions, right? And GitHub Actions is a general purpose kind of an automation product which you can use for either workflows, collaboration, or even for CI/CD and things like that. And you can use this, on Azure, you can use this on AWS, you can use it on Google Cloud Platform, DigitalOcean, Red Hat, OpenShift, IBM, and a whole lot of other platforms, right? So one of the key things, that I also want to call out here is that GitHub is still, an independent platform and an independent organization as well, where we are supporting developers across the world who use whatever developer tools they're using, whatever cloud platform they might be on. So, it's very much the same. If you look at all of the products which are there that we offer, right now on GitHub, be it Actions, be it code spaces, which is in beta, and or whatever it is, it's you can use this across any cloud platform or any supported one. So in fact, if you go on the GitHub marketplace for apps and actions, you can see a whole lot of actions from Red Hat, Google Cloud Platform, AWS, DigitalOcean, and pretty much anything else. You can see integrations with Jira, Atlassian, and a whole lot of stuff as well, because whatever developers want, is what we're helping with. I hope that answers your question.
And one last question, one question we got, that is, can you name some open source organization in which I can contribute using JavaScript? Sayan, can you just answer within 1 minute or less than 1 minute?
Sure. There are organization as in I would say the JavaScript ecosystem is very big. And it depends what's your usually when you start to contribute, the first thing is the interest area, and based on interest area you usually pick up the projects. One that comes to my mind and is a very brilliant project, I would say, is Babel. The Babel community is very helpful. It's around compilers, so I am personally interested in around compilers, so that's something I have been digging into, looking into, though it's JavaScript. But the community is very welcoming. I've seen a lot of Indian folks who contribute there, and I met the maintainer as well at the Copyleft conference again. And that's one I would say from that you can contribute to. And other than that, GitHub has this very beautiful feature called their trending repos, and you will usually find repos which are very active community. And if you're looking into going into that community, I would say that's a definitely pick. Go check out the trending projects, and from there you can pick one and start contributing and stick to it. And it takes time to contribute, but if you stick to it, eventually you will see the fruit.
Yeah, just adding one point there. If you want to contribute to any free and open source software, do not think that you first need to contribute back as code. There are a lot of things that you can do for any project, even creating a graphic image, or changing text, or do a spell check, testing the software. There's a whole lot of things that you can do. So do not think that coding is the only way that you can contribute back to a community.
Thank you. So actually we are even taking more time on this discussion, so I'd like to wind up this. So This was really a fruitful discussion, and I hope that you got an idea on how to get involved, contribute to the open source ecosystem, and also what are the types of licenses and what are things a newbie should be aware of. I mean, entering into an open source community. So, and yes, we are really stoked to have you here, much more of a beginning than an end, as we are expecting many more conversations together. Thank you all and happy learning. Thank you so much.
Thank you.
Thanks, Sonia. Thanks, Matthias, Sayan, and Vimal.
Thank you.
Thanks, everyone.
Thanks, everyone.
Have a great rest of the conference.
Bye-bye.
And also to the audience, if you have any more questions, I would like to get it in offline, and we'll get back to you soon. So if you have any more questions, you can post it in the chat box as well. Thank you.
Hi, Kunal. Are we good to start?
Yeah, we are good.
Yeah. So Kunal Kushwaha is a BTech Computer Science and Engineering student at Maharaja Agrasena Institute of Technology, New Delhi. You might have seen him through Code for Course, and we're happy to say that Code for Course is the YouTube streaming partner for this event. He is an MLH Fellowship team leader. He has also been a Google Summer of Code mentor, and he has instructed thousands of students for Python machine learning development through his Code for Course channel. So he's the founder of Code for Course, and we've seen that there are a lot of discussions happening, a lot of talks and tutorials happening with Code for Course. So Code for Course is an initiative to contribute to the open source community by providing training and guidance. So it is a very good initiative. You can watch the videos and be part of the community. So over to you, Kunal. The stage is all yours. Thank you.
Cool. Thanks for sharing. All right, let me just share my screen real quick. Just 1 second. Cool. So this talk is basically about open source. How as a student you can get started with it. Let me just share my screen again. Cool. So welcome everyone to this talk. My name is Kunal, and really excited to be here. So this talk is about how you can get started with open source in general, and happy to answer all your questions as well. So we'll talk about what are some best practices, how to find an organization, how to find a project, and how to in general just get started. What are some best practices and prerequisites, how to understand a large code base, for example, so on and so forth. So this is a talk that I really like by Linus Torvalds, which is that in real open source, you have the right to control your own destiny. And that is true. So let's first talk about what is the criteria for open source projects. It does not always mean free, because, it totally depends on the licenses. Open as in free to access, for example. Modify, it's an inclusive community, so means for anyone from everywhere. And open as in for open for reuse. Okay. And the next question is, why embrace open source? Because, well, you get the quality and reliability, the security and stability, you get the adaptability and customization, you get the freedom, flexibility, and the most important thing, which is the cooperation and community. This is the most important part specifically for students, because open source is a great way to get real world experience from the comfort of your home. And it's like a great way to do that. These are just a few examples of some open source softwares. And this is the open source development model. So for example, there are a few project maintainers, and then there are a few volunteers, and the volunteers are us, so who are contributing to their projects. And then the project maintainers, they review our code, and then they merge our code into the main project. So they give us feedback, and they give us request changes, for example. And when everything looks good, they merge our code in the main project. Let's talk a bit more about like why contributing is important. So it's more like going to be an interactive session. This slide is not very long. I want it to be like more of an interactive session, and so that you can ask your questions in between after the session is over. So make sure you keep your questions ready, and I'll be more than happy to answer those. So next thing is why contributing is important. Well, because you get real world software development experience, you get the community bonding, the exposure, and you get to test your skills, and you get the satisfaction as well that the code you're writing is being used by people around the world. So for example, like let's say you're learning web development and you want to see, okay, am I really good at web development? What if I was given a really big project? Would I be able to understand? So one way to do that is via open source. Let's talk about the prerequisites a little bit more. So yeah, so the prerequisites include Git, which is a version control system, a programming language of your choice, and a basic to medium knowledge of your tech stack. Now, this is something that I'm saying like basic to medium because you don't have to be a pro in order to start with open source. Even beginners can contribute, and you can even make like non-code contributions, for examples. So non-code contributions are also valid. So for example, like documentation changes, community work, contributor experience, and all these other things. So how to choose an organization, or how to choose a particular project. So if you just go to like github.com, or you can also go to like Summer of Code with google.com. So in GitHub, you can explore the repositories, go to the Explore tab. You can see all the topics over here. You can also see all the topics related to a particular language, for example, React. Okay. So here you can see there are so many repositories for React. That's how you find open source projects. Another way is going to Google Summer of Code website, click on the organizations tab, and just write here whatever you like. So let's say you like Java. So when you like Java, you'll find all these organizations that use Java. And the next step is basically just select any one of these organizations, go through all of these, see which one you like, click on Learn More and See Projects. It will bring you to this page. Then click on Idea List. Don't worry about this thing because these are like technologies used in all the projects, not just one project. So here you can, these are checked, in the Idea List, you can check all the projects that are currently active. Click on any one of these projects. So you can click on any project you like. And then you can just click on the GitHub repo. For example, Code for Cause is also participating in Google Summer of Code this year. So you can check out all the things like what is required to be done, what are the knowledge prerequisites, skill level, project chat, and all these other things. Cool. So that is what you need to do. And you need to like then go to the issues tab, for example, and click on beginner friendly issues or good first issues. Currently, they were like only 2. So you select all these issues. In case you're not able to find good first issues, hop onto the project chat and ask them, hey, can you suggest me some beginner friendly issues to work on? That's pretty much about it. As simple as that. There are like 2 approaches. For example, top-down approach and bottom-up approach. First, you learn the skills, then you choose the organizations that uses those skills. Another thing can be you choose the organization first, and then you learn the skills that are used in that organization. Both of these things go hand in hand. You have to, work hard, and you have to learn about various trends of the organizations, respectively. 3 pillars for any successful integration into any org. For example, for starters, like join the mailing list, their channels, public channels, so that you can ask your doubts over there. Search for projects is something we already looked into. And this is the thing that is the developer lifecycle. So find issues, or you can also create new issues. So coding is, and sending a PR is not the only way to contribute. If you're creating new issues, that is also a valid contribution. Fix that issue and then send it a pull request and keep doing that. Few things that I wish I knew about open source before I started. You don't need to be a pro, and you don't need to be from a computer science background. You don't need to understand the entire code base in order to contribute. Interact as much as you can with other developers, and also never be rude, and always follow the code of conduct of the organization. Cool. So yeah, feel free to ask your questions. Almost done with the slide. And this is true as well for open source projects like bigger projects, that most of your time is going to be spent in research. So like studying the trends of the organizations, learning new technologies, and understanding the entire code base. For example, so you're going to be spending much more time in reading code than writing code. That was it for today's session from my side. The rest of the time will be spent in Q&A. And if you want to connect with me, you can connect with me on Twitter, and do check out Code for Cause, do check out, other social media handles. And yeah, thanks for having me. And now I'm more than happy to answer any questions students may have.
Yeah, participants can unmute your microphone and you can ask the questions directly to Kunal, or you can post your questions through the chat box.
I have a question for you. After a few years in open
Oleg
source,
is here. Saw you just now. Hello.
no trolling this time, be sure. Yeah. So over the past years, what is the biggest highlight for you as open source contributor? From your experience, what was the biggest thing?
For me as a student, the biggest thing has been how inclusive the community is. So if you're contributing to any project, be that like any bigger project like from CNCF or Linux Foundation or Red Hat, for example, that has been the highlight for me, that they are very welcoming. And as a student via open source, I have gotten a lot of opportunities. So even like my current internship I got that via my open source profile. I believe that has been my highlight. Like it has opened a lot of doors of opportunities for me. As a student, that's really valuable. And I met some amazing people like Oleg himself, very helpful people who are helping the community and helping more people get started with open source and stepping in the projects. For example, there are so many mentorship programs also. So I'm going to be graduating next year. Still a lot to learn and lot to see what all things come my way. But yeah, it's been really exciting. It's a good question.
Thank you.
There's a question in the chat. How to take part in discussion forums? Where do we find that? You can find that in like the project README files or the project website, most probably. How do we take part in discussion forums is just always follow the code of conduct first of all, and always ask questions in public. Make sure you ask good questions and provide enough context. So it's not like you're just sending a hi and not enough information is being provided. So if you're getting stuck in an issue, first try to Google it, try to solve it yourself. Then if it's not getting resolved, then ask in the public channel that, hey, I'm facing this issue and I tried this, but still not able to resolve this. What do I do? Other than that, keep conversations public. If you're working on an issue, then keep the conversation in the issue. For example, using comments, tagging relevant people, and be patient because it does take some time for people to reply. It might be also possible that your PR will be pending for merging for months and months. So just be patient. That's what I would recommend. And the question is by Ivan, what are the best projects to be involved as a beginner in open source community? Forget about this mindset of being a beginner. Don't look for beginner friendly projects, because even the more complex projects, even like Kubernetes, for example, that also has like beginner friendly issues. And if you're open source is much more than coding, it's also about like the community part. So I would recommend do check out the bigger projects, even as a beginner. That's totally fine. If you know Git and GitHub and basics of a programming language that the project is using and just a little bit, 30 to 40% of tech stack, get started, learn on the go, learn while contributing, interact as much as you can with other developers. These bigger projects also have their community meetings, regular community meetings. So you can attend those and you can, ask your questions over there. You can also check out various mentorship programs like Google Summer of Code, LFX, CD Foundation has its own program. For example, Outreachy has a open source program. There's the MLH Fellowship. So many programs are available. So try to look into that. But as a beginner, I would recommend, don't limit yourself. Just directly jump onto the, bigger projects is totally fine. You can learn on the go if you know Git and GitHub. Any other questions?
Kunal, can you just brief on the activities of Code for Course? How can students benefit from Code for Course, especially you've been hosting a lot of discussions, talks and workshops through your YouTube channel?
Yeah, I'd recommend, there's a lot of initiatives I'm running currently. So Code for Cause is one of those. It's basically focused on guidance and mentorship for students. So like making the most out of the college life, sharing learning resources and live courses, for example. We have a podcast playlist as well where we conduct podcasts. And we had a nice Spring of Code series where we actually got project maintainers on the channel, and they were sharing with students how people can contribute. So Jenkins was there, CD Foundation, even hardware projects like Arduino and other hardware projects. So you can check out the channel if you want. And another thing I would recommend is that in case you're interested in like the cloud native world, so we have the official cloud native students group as well. So we hold regular meetups related to cloud native technologies for students. So you can join that particular meetup group. That is what I would recommend for now. I'm also starting another channel that is much more focused on only hands-on content. So even though Code for Cause is related to specifically for students, this one will be more like software development focus. Other than that, just be active on like socials, whatever project you're contributing to, interact with their maintainers and see what they're working on. Just getting involved is the first part. People often ask, how do we get started? It's like everything is provided to you. All you need to do is get started. Just get involved. Just even if you don't have any inputs to give in the meetings, just attend the meetings and watch watch what other people are working on, and then you can also start contributing.
Again, on the point that you've told, like you have to straight away jump to the open source project, being it a simple project or complex project. But I think that is a point where most of the students are like taken aback from joining into the open source ecosystem. So what would be your suggestion? What should be the initial and the foremost step to start contributing to the open source ecosystem?
Just getting started is what I'm saying. There is no other shortcut. Specifically talking about code contributions. So I got this question this one time. This student was asking me, hey, Kunal, I'm not able to understand the code base of this project. It's using React. And I asked him, do you know React? He said, no. Then what other solution do we have other than learning React, right? So if the project is using a few technologies and you're not aware about that, learn about it. Ask questions. So many tutorials on YouTube, so many courses on Udemy, for example, so many other courses and everything. That is the first step, having an open mind, because that is important when you're starting with a big project, because as a student, you'll find yourself in a place that most of the technologies that are being used, you don't know much about it. For example, when I started contributing to the Kubernetes Java client, I only knew Java, and I started like learning on the go and learning about Docker, Kubernetes, and then applying. And one more thing is, before actually contributing, use the project. You will find it very difficult to contribute to the project if you don't know what it does. So that's another important point.
Thanks, Kunal. Do we have any more questions from the audience? Please feel free to unmute yourself and ask directly to Kunal.
Yep, no worries. In case you don't have any questions, you can ask me later on Twitter. I'm mostly active over there. And just the important thing is get involved, get started, ask questions. Don't be stuck in the tutorial hell and the learning loop. Learn while contributing, learn on the go. It's going to really, really help you.
Thanks, Kunal. Thanks for that wonderful session. We had a lot of takeaways from that. Thank you so much. Looking forward to associating in future events also. Thank you.
Cool.
Yeah, so we have come to the end of the first day of the first edition of Open Source Summit, hosted by Saintgits College of Engineering and Fossasia. We hope that the session had been beneficial for you. Looking forward to your active participation in the coming days. Tomorrow we have some exciting sessions coming up. We have keynote sessions from Edgar Riba, Rohini Gaungar. We have Ibrahim Haddad from LF AI and Data Foundation, speaking about AI projects of LF AI and Data Foundation. We have 2 workshops in the afternoon. One is purely based on GitHub, and one is on the open Eventia platform. So I hope that we'll have a better participation tomorrow. Thank you so much for attending today's session. We'll see you tomorrow. Thank you, Oleg. I hope you'll join tomorrow also. Thank you.
Let's see. Thanks all.